Hello,
Hello,
everyone. Wow,
welcome. Great to see you. Welcome to the remote second edition of JS Game Dev Summit.
it's so exciting to be here. Let's just introduce ourselves first. I'm going to start. My name is Sahar Purnase, and I'm super excited to be your MC again this year. I'm actually an Android developer living in Tehran, working remotely with Sweden, and I have a huge passion for games, playing and also creating them. I used to play around with Phaser, but now I'm just in love with Godot, and my heart goes to creating multiplayer games the most. And actually, my brother and I create our own games and projects under the name of Gearback, and that's the t-shirt right here. I don't know if you can see it. And also, enough about me. I'd really like to hear about you, Matt.
Great intro. Thank you for that, Sahar. I really appreciate it. So cool to hear about you making games. It's amazing to join you this year for our JS Game Dev Summit. My name is Matt Hackett, and I'm the author of How to Make a Video Game All by Yourself, a #1 Amazon bestseller. In addition to making games, in addition to writing books and drawing pictures for books, I love making video games. And the way I like to do it is I love free open source game engines like you, Sahar. But these days, I write pure vanilla handwritten JavaScript, which is why I'm so excited to be here at JS Game Dev Summit.
Wow.
The grand total for our attendees this year, 5,280. That's honestly so amazing to me because back when I started making JavaScript games in 2010, there were only a few dozen of us in existence. So that's why it's so exciting to me to see so many awesome fellow JavaScript game developers here at JS Game Dev Summit.
Wow, that's really amazing. And what's even more amazing is that all these people are here from all over the world. I just love how we are all tuning in from different time zones. Some of us, like you, Matt, have gotten up pretty early, and some of us are staying up really late to join. So right now it's about 5:33 p.m. in Tehran. Matt, I wonder what time is it over there?
It's so early here in California. I had to set my alarm for 5 a.m. for me,
Oh,
but it's 7 a.m. now and I've got my coffee, so I'm ready for the summit.
that's awesome. And all of this, getting all of these people from around the world, it wouldn't be possible if it wasn't for these guys, our amazing program committee. And without them, it wouldn't be possible, really, not at all. So I want to give a huge thank you to these three amazing people, Bjorn, Andre, and Clement, for their amazing work and awesome jobs that they're doing. So please give a big round of virtual applause to all of them.
Woo!
Thank
Thank you
you.
all. So we, of course, have to thank our wonderful sponsors. We've got Crazy Games, Focus Reactive, Pokey, and Evolution. Let's also make some noise for our media partners for spreading a word about today's summit. Woo! Thank you.
Well,
Now, I'd like to introduce you to Slido, the platform you can use to ask your questions to our great lineup of speakers. It's very simple. Just go to slido.com and enter code 0928. That's today's date to help you remember. Then you select the pixel track, type out the name of the speaker the question is for, and then type out your question. Personally, I'd love to know where in the world you are. So where are you? Head over to slido.com, use code 0928, and let us know where you're coming from. We'll cover the results later in the summit.
all right. And also, we want to see Twitter full of today's event. Please show us how and where you're watching. Tweet the picture of your setup with the hashtag JSGameDev Summit, and we'll be looking out for all of your tweets because we'll have a raffle afterwards for multi-passes to Git Nation conferences. Two winners will be picked randomly. So search Twitter for hashtag JSGameDev Summit to see our setup too. And we'll show it to you right now. Here's mine. This is my setup. It's a small one, but I love it. I'm a huge fan of Doom. You can see that from the posters and the wallpaper.
I love Doom. So good.
Yeah,
John
actually,
Romero, one of my favorite developers ever. That's
yeah.
amazing.
I'd like to see yours now.
Oh, here's
Oh,
me. I'm
great.
at home. I'm making games. I'm writing my book, and I'm preparing for JS Game Dev Summit.
That's awesome. You have a great setup.
Thanks. All right. Submit your own selfie for a chance to win one of 2 Git Nation multi-passes. This excellent prize grants the winners remote access to an array of conferences such as React Advanced, React Summit US, Test.js Summit, React Day Berlin, and many more. Find out more at portal.gitnation.org. You could also win in-person tickets for the upcoming React Day Berlin conference this December in Berlin. So don't miss out on this unique opportunity. But let's get back to today's agenda and preparing for our first talks. See today's schedule. To see today's schedule, you can go to jsgamedev.com and get the info of the day.
All right, so I'm going to help you out a little bit right here. Here's a screenshot of what the navigation on the website looks like. The main screen has the video player that plays the live feed, and you can see on the bottom that we've got a timeline of events that happen in the conference. Now here, below the video player, you can see a track of talks. Here you can see what is live at the moment and what's going to be coming up next. And then there is a track with a speaker's room. Just click on the cells with the speaker's name and you'll enter a special chat where you can talk to the speakers from the interface and type track directly. And then the last one is a track with discussion rooms. We will cover that in a moment. If you're lost at any point, go to the help desk option right in the top of the video player or write us in #troubleshooting channel on Discord. We are there to help you out and make your conference experience awesome.
If you want to hang out with our remote audience, go to spatial.chat. To join any speaker's room, click on the room in the menu. You can also watch the talks together with fellow attendees and discuss them in real time. For all this and more, just visit spatial.chat. Right now, get in on our Discord server. To join, just click on the link in the watch page or your Summit emails. So let's test it out. Head on over to the Discord channels Pixel Track and Vector Track. Post your favorite emojis, your selfies, or GIFs, or simply say hello.
Yeah, and as always, we want everyone to feel safe and have a good time during our event. We have a code of conduct at gitnation.org/COC. Please go read it now. And if at any time you feel there's been a violation, please email coc@gitnation.org. And we will take care of it right away. We do not tolerate any form of harassment in any of our channels. And just a quick reminder about tomorrow's activities. Join discussions on a special chat around such topics as AI in creating games, the future of web game development, art in games, and also multiplayer games with our amazing speakers. I'll be there for all the discussions tomorrow, and I can't wait to see you there. Attendees with full access to conference activities will receive an email with the details on how to join the rooms and participate in discussions.
Your feedback is so important to us. It helps us make the event better and better each year. To tell us your thoughts, head over to jsgamedev.com/feedback. Take your time, write whatever's on your mind, and we'll continue to make a great summit together. Looking to break into the games industry? Check out the many open jobs from our amazing sponsors at jsgamedev.com/jobs. All
right, now we have the answer to our question, where you are all from. That's amazing. Cool. A lot of people from Greece and Germany.
Welcome all. That's exciting.
That is exciting. I don't see my country there. Yeah.
Maybe it's tiny. We'll get more. We'll make it bigger.
Oh, thank you. I feel alone. Yeah, that's awesome. A lot of people are from Switzerland. Oh, wow. UK just popped up.
Oh, there it is. Right in the center.
Yeah.
Welcome, UK.
Welcome, everyone. It's so awesome.
That's really cool.
All right.
Don't forget to submit your questions for our speakers so we can ask them after their talks. When you have questions for speakers, send them over at slido.com and use code 0928. That's today's date. Take advantage of this unique access to these JS Game Dev experts. That's slido.com 0928. All right, here we go. Can we get a round of virtual applause? Let's hear it for Christoph, our first speaker on the Pixel track. Woo! Christoph's talk is called Building the AI for Athena Crisis. This talk will dive into how you build an AI for a turn-based strategy game from scratch. But before we start, Christoph has a question for you. Christoph wonders if you're already using AI when creating your games. This is a really interesting question. I would love to know the answer. Let's everybody head over to slido.com 0928 and let us know if you're using AI to create your games or not. We got a poll going and the data is coming in. All right. Okay, Christoph, the stage is yours.
Oh, hello there. I'm just playing Athena Crisis on my Steam Deck. Thanks so much for joining me for my talk about building the AI for Athena Crisis. I'm Christoph, and I run a small startup in Tokyo called Nakazawa Tech. If you haven't heard about Athena Crisis before, recently at React Summit a few months ago, I did a talk that explains how the game is being built, and it's all built with JavaScript, React, and CSS. I highly recommend, if you haven't seen it, to go back and watch that talk. If we go even further back, if you have never worked with me before, or if you don't know me, I used to manage the React Native and JavaScript infrastructure teams at Facebook, and I built the Jest JavaScript testing framework. We do a lot of stuff at Nakazawa Tech, including building video games, but we also do management and leadership coaching, and we can also help you with your JavaScript problems, for example, with developer velocity, developer productivity, or just help you with whatever problems you might run into while building JavaScript-based applications. So please work with us. Please reach out at nakazawa.dev. But first, before we get into building an AI for Athena Crisis, let's just spend a bit of time figuring out what Athena Crisis is. I'm just here in the game, in the menu, and you can see the overview page right now, and I can jump into a game from right here. And just like that, I can play the game. Not all of the attacks have sounds yet, but some of them do. But the cool thing is, once I finish my turn, let me just build a few units. When I finish my turn, the AI takes over and takes care of their turn. It does attacks, it moves, it can capture buildings, it can do everything that a player can also do. Turn off the music again. So let's figure out how we could actually build an AI like that. The warning here is that this is a code-heavy talk. We'll be talking a lot about code, but at the same time, it'll be beginner-friendly. So please stick with me and as I go through all the pieces. So the prerequisites that I found for building an AI is that you need to have good abstractions. You need to have strong primitives. You need to know about search algorithms, so you figure out where things are in the game, and you need to know about math to, decide on which action to take. And so the way I approach this is that my problem was that I've never built an AI for a video game before, so I had no idea how to do it. And I would read articles on the internet about how they built an AI for like specific types of video games, and it just kind of didn't make sense to me, because these things I feel like are really hard to do if you hard to understand when you're just reading about that, when you just watch somebody else do it. So the best way I found to build an AI is by having all these basic abstractions in place, and then just building it as if imagining what would I do if I'm playing the game. And So the assumptions that I made is that I want to build an AI that's fast, stateless, deterministic, and composable. So I threw a lot of words at you. The way I look at it is that I think if I'm building an AI that behaves like a human player, like the same way I'm playing, I need to have abstractions in the game that I can hand to the AI code that are basically the same as what I'm giving to a player. Of course, it's a bit different because the player sees a map, it's rendered in a browser and all that. But below that, there needs to be a level of abstractions that like you can work with if you're human or if you're an AI. And for that, you need strong primitives. You need to have a map state, you need to have actions. And then if we go back to the assumption is that I wanted the AI to be super fast. I wanted it to be stateless. So it takes one action. It doesn't have any memory. It figures out what is the next action that I can take to maximize my chances of winning. Obviously, a smarter AI would actually have a memory or would plan ahead and like figure out what's the best way over the whole time of the game that I can win. But for now, and for this example today, we're just going to think about how can we make a stateless AI that just does one action at a time. In terms of making it deterministic, the thing that I care about is that there's no randomness involved. Obviously, in the real game in Athena Crisis, there's some randomness in the AI just so that it mixes things up. Because if you tell the AI, hey, go and build the unit that you think is the most useful one to build, then what you end up doing is you build the same unit every time, every turn, most likely, right? So you want to have some variety in the gameplay. So you might want to add some randomness. We're not going to do that today. And in terms of composability, it's really useful for the AI to, for all the modules to be reusable across like the system. So if you're doing something for path searching, or if you're figuring out what's the unit that I should attack that like brings the most value to me as a player, you should abstract those away so you can compose them in other ways. And so if we look at the Athena Crisis architecture, I kind of naturally over time arrived at something where it was pretty a solid base for building like an AI. First off, and again, you can go back to that talk at React Summit to learn more about the basic setup for Athena Crisis, but everything is using immutable persistent data structures. So you have a map state, you transform it, you get a new state back. And so you're not like doing imperative changes on like the map or on the game state. So everything is declarative. You're just telling, here is the game state that I would like to execute. Here's the change I would like to execute on a game state, and you get back a new game state. And these sort of architectures, they also work really well in a server and client relationship, because Athena Crisis is going to be a game that can be played with many people across the internet. And so naturally, a lot of the code is running on the server. For example, the AI that I showed you earlier was running entirely on the backend and is not being sent to the client at all. It only tells you the behaviors that the actions that the AI is taking. And in that sense, it works exactly the same as another player, because when you're playing a game on the internet against somebody else, you don't know the decision-making process they're going through as they take actions. And the AI works the same way, except it runs on a server and tells you the decisions that it made in the end. In terms of optimistic updates, the idea is that the entire client always takes an action at the same time as the server. And like, because there's no randomness in it, that should ideally work. And then all the user experience should feel good. And then let me talk you through this actions, transformers, and action response architecture, because that's the core piece that we're going to work on as we're building an AI. So the way it works is whenever a player plays the game, they take an action. So for example, earlier I was moving my unit around. So moving or attacking, those are actions. Then we execute them against the game state, and we get an action response back. And basically, that just confirms, okay, the player wants to move this unit from here to there. We execute that action. And if we get back an action response, it means that action actually is applicable to the game state. So for example, it validates that you can actually move that unit. It validates that you can move it to that place, and whether that is all acceptable within the game's rules. And then on a per player basis, we're computing visible actions. So I only showed you a basic game map earlier, but there's also a system called Fog of War, where each unit gets a vision range and you cannot see beyond that. So there's a lot of the game state that's hidden from the player based on what your units can see. And the only place that has the full game state is the server, right? And so, you might move a unit from, or like another player might move a unit from A to B, and it goes through a few different fields, but then one of the other players can only see one of those fields. And then when you're computing visible actions, it will drop all the parts of the move that the player is not allowed to see. Then after you compute those, you get action responses for each individual player. Then on the client, you animate them, and then you apply them to the game state. Let me walk you through the code here, actually. So as I showed you earlier, there's an attack unit action. If you execute it, you might get back an attack unit action response. And then this is kind of compressed into like a tuple where it just strips away all the overhead from having objects when you're sending it over the network. There's a code generator that generates these action encoders and decoders for all of the actions in the game. So it's all automatic. And this is what executing an action looks like. So for example, for attacking a unit, you receive the map data structure. You fetch the units from that structure. You ensure that, when you're attacking one unit to another, you ensure that they're not the same player and they're not on the same team. So you're ensuring that they're an opponent. You ensure that the unit that is attacking can actually execute an attack and it's not completed yet. And then, you do a bunch of damage calculation and then you return the stats for the new units. And then when you have fog of war, you have to, as I said, compute whether those actions are visible or not. So there's a definition that I use. Basically, it says if both of the fields are visible, then you can receive the regular attack unit action response. If only the unit that is attacking is visible, then it transforms that action response into a hidden target attack unit. And if only the target is visible, it transforms that into a hidden source attack unit. Those are obviously flipped around because if only the target is visible, then the source of the attack is visible. So it's a hidden source attack. And then later on, there's a bunch of animations involved here. I'm not going to show that today because it's not relevant for building the AI, but we're applying those action responses. So we look at all the action responses, and if it's attacking a unit, we receive all the new unit data. We fetch the existing units, and then depending on the state, we update the unit with the new unit data. Everything here is immutable. And I found that this architecture works really well for building an AI. Here's a quick example. I'm just moving and attacking the pink tank here. So first off, we applied the action response from this position up here and move it onto the bridge. And then we're using that unit that's on the bridge to attack the unit that's next to it. And so that's kind of how the architecture works. So all we need really, if we're building an AI, is to generate a bunch of these actions that are valid for the current game state. This simplifies the problem quite significantly. Because imagine you don't have an abstraction like this where you're applying actions to a game state, and for each player action, you're kind of like manually modifying the game state. You say, okay, attack, and then you just like go in and you like have imperative code that like changes everything in one place. And then if you're trying to build an AI, you have to either like copy that all to your AI, and then you have like problems, but also it provides this common abstraction layer where you don't give the AI access to do anything like cheating, right? So if you're making an attack or executing an attack with this sort of abstraction, the AI cannot have an attack that's twice as effective or something like that if that's not also allowed for the player to have. Of course, you might want to have a system like that, but in a game like Athena Crisis, you want all of the players to play by the same rules. So finally, let's implement AI behaviors. And we do that by, just outlining kind of like the most basic kind of behavior that the AI could have. And we're going to put together a small class. You don't have to use classes here, but it's like a little bit easier. And the first version of our AI can only do one thing. When the AI starts its turn, it ends the turn. And that's a really good way to make sure that the AI stops playing, because otherwise you kind of deadlock the game pretty quickly. So in this case, we're just going to add a single action that is called end turn. And so we're executing the end turn action on the game state. And we're going to add a helper here that's going to be useful for later. So basically we're adding this method act. And if we execute an action here, it adds it to this array of responses. And we can fetch those later and send it to the player. And then the interesting thing here, we'll use this function called action to chain all of our AI behaviors together. And once this function returns null, it means the AI is done. So in this case, when the AI is executing an end turn, we will just return null. And this is how we could use this AI. So we just instantiate a new instance, and then while the current player is a bot, we just action on the map, and then replace. The important thing here is also we have to replace the map with the new game state. And then at the end, we receive all the responses, and we can stream those to the client. So in this case, it would just return an end turn action response. And as you can see here, the game is just looping. Anytime I'm ending my turn, the AI is ending theirs. So now how do we add a move? So for example, we looked at this action function earlier. So now the way we're extending this is that first we're always going to try to move a unit. And if there's no more unit that we can move, so this function returns null, then we'll end the turn. And so the way we can implement a move function is through a bunch of different helper functions. So first off, we'll just get the first unit that's available that we can move. So there, assume there's like a helper function here that like allows us to extract that. And then how would a human play, right? And this is kind of how I thought about how I would play. It's like, I'm going to look at what's interesting on the map. Like, based on the current situation, based on this unit, based on the map state, where does it make the most sense for that unit to go? Once I have this list of positions, I figure out what are the clusters of where I need to go. I'll get into details on that later, but basically I might have like 100 interesting positions, but I need to figure out where to actually go. And so the way this cluster function works is it will take all those positions and reduce them into a smaller amount of clusters where it makes more sense to look into where to actually go. And then based on those, we look at, which target should we actually go to. So if you look at this, is like, we might have a lot of positions. We only have like a few clusters, and then we'll only find one target. And then if we have a location to go to, we'll execute a move action. Otherwise, and this is where it gets really important, we'll execute a complete action. So the important thing here is that each of these functions always needs to return an action. It always needs to mutate the game state. So either the unit is going to move or it's going to complete, which means it won't take any other actions. Because the problem you run into otherwise is if you run this action function in a loop, it will enter the move function and then always try to recompute all of this only to realize there's nowhere to go. So you always need to make sure every one of these functions, when there's no more actions to take, they return null or they mutate the game state so that you can go back into that function to move the next unit. So ideally, as you execute game actions here, the number of available units trends down to 0 so that you can enter the end turn function here. All right, now let's figure out this whole thing about how to actually move. There's a very common algorithm. There's many algorithms to search on a 2D grid about where you're going. I landed on A star. It works really well for this type of game. And the one thing here is that you're basically doing depth first search on a 2D grid to figure out where you should go. And you're trying to do that in the fastest possible way with the lowest amount of cost. So if we just look at the game map, this unit cannot go into the mountains, and it costs more to go into the forest than staying on the street. So we're trying to optimize how do we get from this green tile, from this unit, to over here. In this case, there's only one path, right? But we still need to figure out, okay, is this the way to go? Or should we go through the river? But, this unit cannot go through the river. So once you do this sort of path searching, you kind of have walls, or you have like a higher movement cost on like certain tiles. And then once you have this radius, in this ability to figure out where can this unit go, then we can figure out, okay, what are the interesting positions on the map, and then figure out if the unit can actually travel there. So this is obviously a simplified version of it, but here's like 3 things that you could look at. The actual implementation in Athena Crisis is like a couple hundred lines, depending on the state of the game and the unit that you're asking about what to do. So for example, units can capture buildings, units can attack others, units can supply other units with fuel and ammo. So for example, you might have a system here where a unit that can supply others will think that other units are interesting if they're low on ammo, right? Or in this case, I have this, if the unit doesn't have an attack or it's out of ammo, it is in danger. So if it's at the front lines, it will actually think the interesting locations are the buildings back at where my bases are. And through that, if we feed that into the system that I outlined, that unit will try to retreat. And here, for example, if the unit has the ability to capture other buildings, then the most interesting place to go to is buildings that are owned by the opponent. And finally, if the unit just has regular attacks, most likely it will find other units interesting to go to, like opposing units to go to. And so now let's think about this whole thing with clusters. So on the left side, we have the whole map, right? And so you have like the yellow units here and you have the pink units there. So once we get the interesting positions for this unit to go to, the map will look like this to the AI. It will be like, okay, I think there's a pink one here and a pink unit there. Which one shall I actually go to? And there's a really useful function. This is one of the few times where I'm happy to use a third-party library, because it's a bunch of math that's like simplified by just pushing it down into another library. Basically, you might have like 100 points on the map. In this case, I know we only have 2, so this is like a very simple example. But there's we're just using a k-means algorithm, and there's an npm package called skmeans that is like pretty fast, where we can feed a bunch of positions and then tell it, here's, which algorithm to use and like how many iterations you should take and like how many locations or clusters you should return at most. And then it will reduce those and group them based on like how interesting they are. And then finally, we'll just feed those clusters into a function called find path to targets, where we're actually just going to look at, okay, this unit can only move from one place to one other place in this turn. So let's just find the closest target. And we can just, maybe in this case, use the distance on the grid. But the actual implementation, the way it works is it will actually look at the movement radius, because you might actually have a unit that's really close to another one, but there's a mountain in between, so you cannot access that unit. So you need to actually look at the radius, the movement radius for that unit to see which one is the easiest to get to. And then once we know what's the closest unit, we'll figure out how do we actually get there, and then try to position the unit just next to the target. So in this case, target.parent, this function returns like a list of paths where a list of fields, and where each field has a parent, so you can like navigate it. And we cannot move the unit on top of another one, so we have to move it to the parent of that unit. And then finally, we can piece it all together and our unit moves to the bridge. As I said, we're looking for the interesting positions, reduce those to clusters, figure out a path to one target, and then we execute a move action. Once we're done with the move action, we're ending the turn. All right, and then the other thing that I want to show is how to build an attack. So right now, all we do is the unit is moving. But how do we add attacks? And it's all actually very similar to moving. So how about every time when the AI starts, we first look at attacks. If there are no attacks to take, then we move to interesting places, and then finally we end the turn. So the way I've implemented this is I just, at every point of the game, I look at what's the best attack that has, the best outcome for the current player. And if there is an attack available, then we just make sure that either we have to move there, And if the distance is greater than 1, then we first move closer to that unit, and then we attack that unit. Okay, so how do we actually figure out what's the best attack? Here's a basic implementation for figuring out the best attack. First off, we look at all of the units that the player has, and then we figure out, okay, earlier I showed you the A* algorithm, and we can extend that to not just give you the movement radius, but also the attack radius, which is usually the movement radius plus 1 field on each side, something like that. And then for each unit that other unit can attack, we figure out what's the likely damage that we can do, and then we assign a weight to it. And just stick with me for a moment. We just assume that the maximum damage has the highest weight. And then we push that into a list of possible attacks, and then we just return the one that has the highest weight, in this case, the highest damage. But it might not be ideal to just always think about doing the largest amount of damage. So you want to actually introduce weights. And so in this case, depending on the game state, it might be more valuable to attack certain units in a certain state than it is to attack other units. So for example, if you're defeating that unit, it is much more important to actually execute on that action than if you're just reducing its health by a little bit. And this is slightly more complex calculation, because what I found is that you don't want to have the maximum kind of damage to a unit that's already damaged. You actually want to find the unit that can do the least amount of damage to a certain unit to take it off the field, because that reserves other stronger units to do more stronger attacks on other units later. And another thing that I found is that, you want to skip very low damage actions, because you might just have a unit that runs into another unit, does no damage at all, but then the counter attack is so strong that that unit gets taken off the field. So you might want to prevent that too. And then it gets much more interesting here on this side also is, okay, what if there's a building here, and then there's an opposing unit on that field, and that unit is trying to take over your building? That is probably much more important than taking out a random unit that's completely somewhere else on a field. And then, there's a bunch of cases where, if this unit is transporting other units, or if the building in question is if the building where that unit is at is your own headquarters, you're most likely to lose. So we'll prioritize that. Or, in some cases, some units have the ability to attack and others only have other special abilities. Most of the time, it's more important to attack those units. And then we piece that all together, and then we'll see how our unit is moving and attacking that other unit. All right, so I showed you how to, add an AI to a video game, how to move it, how to execute attacks. What would be next? So first off, you'll want to support all the unit and building capabilities that the game has, so that the AI has the same capabilities as a human player. We haven't thought about fog of war at all in this AI. We actually have to make sure that the AI doesn't get information that the player doesn't also have. So we need to remove all the information that is not visible to the AI. One thing that I found to be really fun, that I thought was going to be really hard, but then turned out to be relatively easy, is to add customizable AI behaviors. You can make an AI more aggressive or defensive or passive, or you can adapt its style depending on the game state. When it gets attacked, it will change from defensive to aggressive, something like that. If you have been following this and you're interested in building an AI, I highly recommend you to build your first version and then think about, okay, how do I make it defensive, or how do I make it more aggressive? It's really fun to tinker with that and to see what kind of outcomes it has to adjust the small weight of prioritizing one thing over another. And then, finally, as I said in the beginning, we just want this AI to be fast and stateless. and composable, and it doesn't do any sort of planning. It doesn't look back. It doesn't have a memory. It doesn't think ahead 5 turns of like, here's the smartest move I could make now that will set me up for success later. So, real AIs in video games most likely do some sort of optimization to predict what's going to happen in the future. They plan like what's the best action, not just now, but also if we think down, like depending on how the game might evolve. The problem with that is that it tends to become really slow because the AI has to think really hard. Like, what if I'm moving this way and then, the opposing player has 5 options and like they might take one of those 5, which then generates 7 options for me. And then you kind of have this explosion in terms of like decision making. So it becomes really slow. But I hope that this overview was useful to you if you've never built an AI from scratch, to just figure out like, okay, this is kind of how you build an AI for a 2D turn-based video game. Now the next step could be, how do you build an AI for a real-time strategy game that's maybe also built on a grid or something like that. One more thing I wanted to share is that this entire talk was designed with React and MDX. I built a system called ReMDX that you can use to make slide decks, and you can find the source for this entire presentation on GitHub as well. And again, I'm working at Nakazawa Tech, a small startup in Tokyo. If you'd like to work with us, please reach out. Thank you so much.
All right, Christoph, thank you so much for that amazing talk. And please join me on the stage. Welcome.
Hey,
here we go. Great to meet you too. Thanks so much for joining us. All right, so we got the Q&A portion here, and here are the results of the questions that you asked the audience. So looks like we have a majority not yet. Not surprising. It's pretty new tech, right? Is that aligned with what you were kind of expecting, or is that totally unexpected to you?
No, it sounds about right. I think this is really good because the idea of my talk was to be beginner friendly, so that people who have never created a basic AI for a video game will get an idea of how to do it. If you're just starting from scratch, that's how it was for me. Like, I had no idea how to do it, so I just had to build it to learn about it. So I'm hoping my talk was useful to 3/4 of the people that haven't created an AI yet and now have an idea of how to get started. That's perfect.
Very cool. Yeah, I haven't yet. I know it's very popular right now, and we're going to see a whole bunch of games, a new wave coming soon. Very interesting stuff. defeatacrisis.com. Game developers need those wish lists so much. So let the devs know you're interested by wishlisting the game. Okay, before we switch gears to our second speaker, make some noise for our gold sponsor, Crazy Games. Woo! On Crazy Games, your game could reach over 25 million monthly players. Wow. To submit your game to Crazy Games, head on over to developer.crazygames.com.
All right. And please do not forget to ask your questions to our speakers. We'll ask them to the speaker after the talk. And use code 0928 on slido.com. All right, we have our next speaker. We have Tom Glenn. Tom is a software engineer and game developer with a passion for creating games and sharing educational content. With 15 years of experience in the industry, he has honed his skills in Unity, Unreal Engine, and Godot. As the lead engineer in Heroic Labs, DevRel team, and creator of the popular YouTube channel Code with Tom, Tom creates engaging educational content to empower the next generation of game developers. Now he will talk about supercharging your game's social features with Nakama. And before we get to the talk, I want to ask you a question. So Tom is interested if you are using some WASM compiled library for web tools or web apps development. So please go to a Slido and answer his question. And now, Tom, please, the stage is yours.
Hi, I'm Tom, and welcome to this talk on how to supercharge your game's social features with Nakama. Before we begin, let me give you a brief background on who I am. I'm Tom Glenn. I'm a software engineer with roughly 15 years of experience across a wide variety of sectors, including web development, banking, 3D simulations, and more. I'm also an engineer and part of the developer relations team here at Heroic Labs, as well as a content creator and educator over on YouTube, and you can find me at Code with Tom. So, who are Heroic Labs? Well, we're a team of roughly 40 people and creators of the open source game backend Nakama. We power some of the largest multiplayer games across mobile and desktop, and our clients include the likes of Paradox Interactive, Lightheart Entertainment, Lion Studios, and more. Our other products include our LiveOps platform Satori, as well as our game framework Hero, and Heroic Cloud for our managed server hosting. So, what are social experiences? I've no doubt you will all have experienced these before, but social experiences in games can include things like being able to add friends, participate in leaderboards, chat to other players, join groups or guilds, complete achievements, and show them off on your public profile, take part in live events, and so on. There are so many different kinds of social experiences that you can encounter in games today. But why are these important? Well, multiplayer and cooperative experience have been shown to increase the amount of time that players spend in your game. And social competitions such as leaderboards keep your players coming back for more. They can also allow your players to form communities with shared interests and experiences, and this can lead to an increased player base as players are incentivized to invite friends, share achievements, and collaborate to complete goals. Social features such as gifting or live events can also drive in-app purchases and open the door for other monetization opportunities. So rather than talk to you about the theory of adding social features to your game, what I want to do is give you a practical demonstration of how you can add multiple social features to your game using Nakama. We're going to quickly run through how to add authentication, adding and listing friends, viewing a global and a friend-specific leaderboard, submitting scores to that leaderboard, and then rewarding that player participation by giving the player some coins for participating in that leaderboard. So let's jump over to the code. Okay, so you can see we've got our demo application running here. It's a simple React application with a login screen that if I try to log in right now, nothing's going to happen because we haven't implemented any of these functions here, which the React application is expecting to call to perform various things such as authenticating, getting the account details, adding a list in friends, and so on. So what I'd like to do is quickly run through how easy it is to implement these functions using Nakama. So before I start, what I have done here is I've ran npm install and I have installed the Nakama.js package, which you can find at heroiclabs/nakama-js. Once you've done that, we can then import the client and session object from the Nakama.js package. We're then going to create a client object. Now, this client object expects to take a server key. The default one is default key. The host address of the Nakama instance, in which case I'm currently running this using Docker on my local machine, and the port number for where the Nakama instance is running. We're then going to implement the authenticate function. Now, Nakama supports various different mechanisms for authentication. These include device authentication, email and password, Apple, Google, Facebook, and custom authentication, to name a few. We're going to use custom authentication here just because it allows us to pass in a custom identifier as well as a username. And this true flag here also allows us to specify if the user account doesn't already exist, then we will go ahead and create it. Now, this authenticate custom function, as well as all of the other authenticate functions, will return a session object, which you can see we have up here. This session object allows us then to call into various other functions within Nakama to get different pieces of information for that user account. If we save this file now and come over to our login screen and try and log in again, you can see that we are now logged in. It says, "Hi, Code with Tom." We can't access anything such as friends or leaderboard right now as we haven't implemented those functions, but let's go ahead and do that now. I'll just quickly log out. And before we go any further into getting an account or anything else, what I'd like to do is implement a restore session flow so that the next time the user comes back to the application, they don't have to relog into their account. To do that, we're going to get two items from local storage. These are going to be session token and refresh token. Now, we're also going to have to set these items. So what we'll do is just after we authenticate, we will go to local storage and set the session token as our session.token value and the refresh token as the session.refresh token. We'll also implement a function here called restore session. And what we're going to do here is we're going to get the two values for session token and refresh token just to make sure we have the most up-to-date version. And if they have a value, then we're going to use the session.restore. Now, this is a function that lives on the session class itself. Pass in the session token and the refresh token and assign that value back to our session variable. We will save that and let's log in here, Code with Tom. And you can see now if I refresh the page, I'm automatically logged back in, which is great. Now, the last thing we need to do is implement a logout function, and that is our authentication flow complete. To do that, we are going to call the client.sessionLogout function. This takes our session object as well as the token and refresh token. We're then going to nullify our session object and then just remove those tokens from the local storage. So let's just refresh that here and log back out. And you can see we have now been logged out. And if I refresh that page, we no longer log back in as Code with Tom. So let's just quickly log back in. The next thing we want to do is implement the get friends list. Now, to do this, all we need to do is call the list friends function on our client object. We're then going to check to see if the result contained a value, just to make sure that we have a value coming back from the server. And we're going to filter it for any friends that have a state of 3. We don't want any friends that have a state of 3. Now, you can head over to the Nakama documentation and have a look at what the friend states are, but these can include a mutual friend where you've both added each other. It includes a sent requests when you've sent a friend request to somebody else, a received request when you've received a request from someone, and 3, which is banned if either user has blocked each other. So we don't want to include any users that have blocked each other here. If we find no friends, we're just going to return null. Now, if I save this and refresh, we're not going to see anything because we haven't added any friends yet. So how do we do that? Well, we can simply call the add friends function, client.addFriends. We pass in our session object. This one here is the ID, user IDs for any users that we would like to add as a friend. So you can optionally add friends by ID, or you can do it by username. In this case, our function is expecting to take a username, so we're just going to add them by username. So let's save this, and then if we try and add a friend now, there are no other users in the system. So what we'll do is we'll quickly log back out and we'll add another user. So let's call this user test user. We'll log in and you can see now that we can go and add a friend. So let's add Code with Tom. And you can see that we have one friend here, Code with Tom, and we have sent that request. Let's log out and log in as Code with Tom. Now you also notice here I'm not using a password. That's just because we're using that custom authentication flow. If you wanted to use a username and password, then you can use the email and password flow as well. You can see here we've received a request from test user. Now in order to mutually add that user back, all we need to do is just come in and add them as a friend as well. And that creates a mutual friendship. So that is how quick and easy it is to add a friend system to your game. We have a full add and send friend system here, as well as being able to list all of our friends and their current statuses, whether or not it was sent or received. The next thing we're going to do is we're going to add in the get account function. Now, what this will do in this particular demo is it will display our current wallet. Now, I won't have any coins because this is a brand new account, but let's just implement that function quickly anyway by calling the client.getAccount function. This takes our session, and as part of this, we can just quickly take a look. The result here, we can get all of the information about that user. So we can say what their email address is, what their wallet details are, and we can also go in and get various things such as their avatar URL and so on. Let's just delete that line there. And now this will be implemented. So the next thing we need to do is implement our leaderboards functionality. So the first thing I would like to do is implement the list leaderboard function for our global leaderboard. And what we're going to do here is we're going to say list leaderboard records. We're going to give it our session token, and we're going to pass in the identifier for the leaderboard that we would like to get. In this case, we have a leaderboard set up on our Nakama server called weekly_leaderboard. Now, we're going to pass in null here for the owner ID's value, which means that we don't want to get leaderboard records for specific users. We just want them for everybody. And 100 is how many records do we want to receive from that leaderboard. So we're going to say we want the top 100 records. We're then passing back the result.records object here. And if I refresh this and go to leaderboards, again, you're not going to see anything here because nobody has submit a score yet. So let's quickly add the submit score function. Down here, we're going to call write leaderboard record. We're giving it our session. We're giving it that weekly leaderboard identifier again. And we're going to give the score value, which is going to come from this input field. Now, obviously, in this case, we're just submitting a score directly, but you would submit a score at the end of your gameplay mechanic. For example, when the round ends, you would then call this function with whatever score the player has achieved. So let's save this and refresh. If I come over to the leaderboard now and submit a score of 100, you'll see that Code with Tom is now in rank 1 and has 100 points. If I come to the friends leaderboard, you'll see that there is nothing in here right now because we haven't implemented the get friends leaderboard function. So let's quickly do that now. This one's going to be a bit more involved, and I'll run you through how it's done. So first of all, we're calling our get friends function, which we implemented up here. If there aren't any friends, then we're just going to return nothing. Otherwise, we're going to go and map all of our friends and get all of their user IDs. We're then going to add ourself to the user ID list, just so that we can include ourselves in that ranking. We're then going to call list leaderboard records, again, passing in the session and the weekly ID. And then we're going to pass in the friend IDs where that owner ID's parameter is. And this is going to mean that we go and get their specific records from the leaderboard. Again, we're going to say 100 records. And then what we're going to do is instead of returning result.records, we're going to return result.ownerRecords. Let's save that and refresh the page. Come to leaderboard and go to friends. Now you can see here that I can only see Code with Tom. That's because our friend test user has still not submitted a record. So let's log out and go and submit a record for test user. If we go to the leaderboard, we can see Code with Tom. If we go to the friends leaderboard, we can also see Code with Tom as Code with Tom is in our friends list. So let's submit a score of 500. And you can see now that we're now rank 1 and Code with Tom is rank 2. Perfect. So that's how we can implement a bunch of social features in our game very quickly using Nakama. Everything you've seen so far has been done with client-side code. However, Nakama is extremely flexible and does allow you to extend the game server itself using TypeScript. You can write your own custom code, your own functions, or interact with the Nakama lifecycle hooks to do various things, such as provide daily login rewards when the player first logs in for the day. Or you might want to add a profanity filter to chat messages just before they get sent. You may also want to add things such as guild creation requirements, thereby restricting players from creating guilds or groups until perhaps, say, they reach level 10 in your game. What I'd like to do now is show you a practical example of how you can extend Nakama by implementing a player participation reward for whenever the player submits a leaderboard score that's greater than or equal to 1,000. When that happens, we're going to give them 1,000 coins in their virtual wallet. Let's dive back over to the code. So in order to implement our player participation reward, we're actually going to use a after hook. Now, this is going to be a hook on our write leaderboard record lifecycle event within Nakama. To do this, we're going to use our initializer up here, and we're going to say initializer.register after write leaderboard record. And then we're going to give it the name of a function. Now, we're going to define this function below. And all this function is going to do is it's going to use this data parameter here, which is a leaderboard record. And we're going to say data.score. And we're going to say if it's greater than or equal to 1,000, then we're going to call the nk.walletUpdate function. Now, this function expects to take a user ID and then a change set for how we want to change the user's wallet. So we're going to pass in the data.ownerID for the owner of the leaderboard record being submit. And then we're going to call the change set function with a value of coins for the key and 1,000 for the property. Now this is going to give them 1,000 coins. Let's save this. And then what I'm going to quickly do is rerun the Nakama instance via Docker. And then if I refresh this screen here, and if let's log out, let's log in as Code with Tom. Let's come over to our leaderboard. And now I'm going to submit a value of 1,000. Now, hopefully we should see that our coins increase. And they do. So our coins there have increased by 1,000. And that is how quick and easy it is to add custom functionality to your Nakama server by writing TypeScript code. The features presented in this demo are just a small surface area of what you can fully achieve using Nakama. Other features you may be interested in include our user profile and metadata systems, online status and presence tracking, storage engine for storing whatever game-specific data you need, chat including rooms, direct messages, and group conversations, matchmaking and real-time authoritative matches, parties, tournaments, and, of course, whatever custom functionality you desire using server runtime code. So, hopefully by now you've seen how quick and easy it is to add social features to your game using Nakama. Social experiences like these can help boost engagement and drive longer, more frequent play sessions from your players. They can help cultivate a community around your game that's invested in your game's success, and they also help amplify the growth of your game through friend referrals and word of mouth, leading to organic player acquisition that keeps player numbers higher. As well as this, social dynamics can enhance the longevity of your game by keeping gameplay fresh and encouraging players to stick around. If you want to get started with Nakama yourself, you can head on over to our documentation portal, which is available at heroiclabs.com/docs. And if you need any help or support, our forum is there at forum.heroiclabs.com, where we can hopefully assist you with any questions that you might have. If you want access to the project source code for the demo that you've seen in the presentation today, head over to GitHub at github.com/codewithtom/JSGS-23, where you'll find all of the source code available. If you'd like to get in touch with me, you can do so with my socials here. But otherwise, thank you very much for listening, and I look forward to your questions in the Q&A.
Thank you, Tom. What an amazing talk. I would like to ask you to join me on stage. Sorry for the mishap.
Hey, nice to meet you. How you doing?
Nice to meet you. I'm doing great. How are you?
Yeah, very good. Thank you. Very good. Hope you guys enjoyed the talk.
Yeah, absolutely. That was an amazing talk. First, I would like to discuss the answer to your poll question. So we have that before we start the questions. All right. So a lot of people, like 60%, around 60% have answered, no, I didn't know of any.
Yeah, I mean, that kind of makes sense. I mean, the reason I asked this question was obviously in Nakama, we support a bunch of server-side code languages, Go, TypeScript, and Lua. And we sometimes get questions around whether or not we're going to support C# or other languages in the server. So WASM is potentially an avenue for us to support some of these other languages there. So I was just curious to know what people's thoughts are there.
Yeah, it makes sense. And surprisingly, like 28% have answered that no, but they know of some. and 17% have answered yes.
Yeah, it's an interesting one. I mean, it's something that we can potentially talk about tomorrow in the multiplayer room. But yeah, it's just interesting to see that, you know, most
Yeah.
people haven't heard of any, so perhaps something that we can do some knowledge sharing on.
Yeah, actually, I can't wait for that. So we have some questions for you, Tom.
Sounds good.
Bye. All right, just one more reminder. We have the second track with talks in parallel, and after each talk, speakers with vector track are joining a special chat to talk to you. So please check that out also.
JS Game Dev Summit is packed with powerful information, so naturally you're going to have questions along the way. Don't be afraid to ask. There are no bad questions. So ask away over at slido.com, room code 0928. All right, time for our next amazing talk. Get ready for our speaker, Olai Inca, and her talk, Game Development Patterns and Architectures in JavaScript. In the realm of game development, the right architecture and design patterns can make all the difference. This session dives into the world of game development patterns and architectures in JavaScript, offering a comprehensive exploration of the techniques and strategies used to create engaging and well-structured games. But first, let's take a look at Olayinka's question for you. Olayinka asks, let's dive in. One more time. Okay. The question is, how many hours per week do you play games? This might be a rough answer for some of us. It might be much higher than we hoping for. For me, on an average week, at least a few hours. Sometimes I go through periods sometimes where I'll play a game like it feels like a full-time job, right? All right, but it's time for the talk. Olayinka, the stage is yours.
Hi everyone. Thank you so much for coming to my talk today. My name is Olayinka Atobile, and today I'm going to be walking you through game design and architecture. So before we start, just to give you a brief introduction of who I am, I'm a fourth year student of computer engineering at the University of Lagos. I'm also a software engineer. I'm a technical writer. I'm a GitHub campus expert. So, and I'm very passionate about diversity and inclusion in tech. And basically, I organize events and programs targeted towards that. So today we are going to be speaking about game development patterns and architecture in JavaScript. So I'm basically going to be introducing us to some common patterns and architectures that can help us speed up, you know, game development in JavaScript. So, what exactly are game development patterns and architectures? So, they are basically reusable solutions that you can use to solve some common problems that we face in game development. Game development can, easily get bulky, and especially as you scale up your games, as your games become, more bigger and more powerful, it can get very easy for it to become, more difficult to maintain or more difficult to expand or extend its features. And basically what having good patterns and architectures does is that it helps you make your code more modular, more maintainable, more extensible. And in the long run, it could even like improve like the performance of your game, how well it performs, how well users are able to interact with your games, and how scalable it is, how easy it is for you to add other features, or even onboard new users to your games. So why are they important? Like I mentioned earlier, game development is a complex task. It is challenging. It can easily get complex. Patterns and architectures, having good patterns and architectures in place will help you simplify the process of developing the games, and will also help make managing the game more maintainable, more manageable. So, and also it could even help you prevent, some common mistakes, having some bugs in your games. So, what are we going to cover in this talk? So, we are going to start with we're basically going to be covering some common and important patterns in game development. So we are going to be talking about entity component systems, ECS. Then we are going to speak about game loops. Then we are going to be talking about decoupling, your game logic from rendering. So now let's start with entity component system. So entity component system, ECS, is basically a popular pattern for game development. So um, entity component system is a software architectural pattern that represents game objects as entities and their components as behavior and data. So these are just big words. So just to break it down, I'm going to use an analogy. So let's assume that a lot of us are probably familiar with Lego games, the Lego blocks. So let's assume that you are building a car with a Lego block, right? So you're probably going to have um, the wheels, the steering, the body, all of those different parts, all of those different components are your components. So basically they just represent, the behavior, they just represent like a particular part, like your data of your entire game, right? Of your entire game. And basically entities are just collection of the components. So when, let's say, you finish, assembling all your different Lego blocks and you have a car. So in that situation, like where your car, which is basically like, collection of the different components, is basically like your, or in this case, your entity. So because it's just like, you are assembling different components together, right? So your different components that basically like represent a behavior, like a particular data, are your components, right? So they basically just represent, one single, piece, to like one single data, one single behavior. And then your entity is basically a collection of some different components that are, maybe represent like a particular entity, a particular object in your game. So just now to bring it back to game development in the world of JavaScript. So let's assume that you are building let's say video game, right? In your video game, maybe you have a car that is moving or something. In that case, let's say your car is going to have your, velocity, the speed, right? You're going to have a speed, you are going to have a position, like where your car currently is at. All those two things are kind of your components, right? Your velocity and your position, they are components. But the car in itself, which is, going to be like, a certain car is going to have a velocity, is going to have a position, is going to have a color. The car itself is going to be an entity because it's basically just, collection of different components brought together. So basically that is the main concept behind ECS. We basically want to separate, different, you want to separate the different behavior and data in your games into components. In that way, it is basically easy for you to pick any components that you need, when building like an entity, or to bring it down an object in your games. It's easy for you to, just, pick different components, as part of the entities, and you basically like, built a new, a new object in your game, like straight out of the box. So basically entities are unique identifiers, like I mentioned, and components are just data that are attached to the entities. So now talking about systems on the other hand is basically just a collection of entities and components that perform a specific task. So just to again, using an analogy, so let's assume that in a situation where you have, maybe you want to perform a task, let's say in the case of a video game, right, where you have like a car in your video game and you want to basically, let's say, move the car. So in that situation, the only component that you really need to perform that task is let's say, position and velocity, right? So in this case, you probably don't have any interest in, maybe the color of the car or how big the car is, because they don't affect the particular task that you want to perform at that particular time, right? So basically what systems does is they are basically just like sort of functions that help you like separate like specific task and the certain components that are related for you to actually perform the task. And basically, and in the long run, what he just does is it makes it easier for you to, manage your code, makes your code like more manageable. So how does ECS works? So entities are created and destroyed at runtime by your game engine. So entities are basically just objects in your games. You add components, your game engines adds, or removes components from it at runtime, that is from your entities, right? And then your systems are updated at regular, intervals, depending on the operations that you perform, or that the user performs within the games. So why is ECS such a popular, is a very popular game development architecture, right? And why is that so? It is a good choice for game development because one, it promotes code reuse, right? I mean, like we explained earlier, you have specifically defined components, which means like you can easily grab a component and attach it to, different entities, actually not just one type of entities. You can easily create and modify game objects. Like basically all you have to do is just your defined game entity and just create a new one, attach some component to it. And it can also help to support efficient data access, just like separation of like all your data into well-defined components, and it can easily be scaled. As your game gets bigger, you can easily scale it. So just to add like a little code example, just to put some sense into what I've been talking about so far. So in this example here, you can see you have a position component, you have a velocity component, and your position component, you can see like you basically just have your x and y axis, right? And your velocity component as well, you have your x and y axis, and then you have your movement system, and those, okay, just going circling back, the components, like you see, they basically are not doing anything aside just representing a component, a particular data in your game, and that's all. And if you look at your movement system, so basically that is basically just moving an entity. So it's basically just, and all it's doing is calling the components that it needs to actually perform a specific task, which is moving. So it's basically just calling position and velocity. So basically this is just a small example of ECX in code. So moving on to another very interesting pattern in game development, which is game loop, the art of every game. So it is called the art of every game because basically it is used in literally almost every game that you would develop, right? And so basically, what is game loop? So you imagine if you are playing let's say a game of tag, where you basically repeat some sequences, again and again. That's basically game loop. So it is basically a repeating sequence of instruction that controls the flow of the game. And literally in almost all of the games that you play, that is what you do. You do something, you do something, something happens on your screen, then at some point, whether immediately or later on in the game, you do the same thing again, right? So that is literally what game loop is, and it is responsible for updating the state of your game, for re-rendering your game, and for handling like inputs from the player of the game. So basically, how does it work? So game loop is basically consists of like different steps, right? So the first step is inputs. So for example, let's assume that I'm playing a video game again, where let's say I have a car that is moving on the screen. And to move the car, I have to press a key on my keyboard. Let's say maybe M for move. I press M. In that situation, that is input, right? The game is basically getting an input from me. And the next step is update. So depending on what I have pressed, I'm pressing in this analogy that we are currently using of the video game. So I'm pressing M. The game receives the M key from me, and as soon as it receives the input from me, it knows that it has to update the state of the game. In this case, that is probably the position, right? So that is the next step that happens, updates. The next step that happens is render. So I've updated something in my game. So I've updated the game state. So the next thing is for the game itself to render, change what I'm seeing on the screen, maybe move the car from its current position to the new updated position, and then sleep, right? Like basically you wait for some time before the loop starts again and again, right? So that is basically the whole idea of a game loop. And then in building a game that involves the use of game loops, you have some different architecture that we use. So one of the architecture is fixed time step architecture. So that basically means that um if we go back to this where we talk about the sleep and the amount of time that you wait before the next iteration of the loop. So in fixed time step, the architecture basically uses a fixed amount of time for each iteration. So that means that it sleeps for, a specified time, a fixed time before it starts the next iteration each time, for all the iterations. And variable time step means that it allows the time to change for each iteration, and that could vary. It could vary depending on maybe what your user types, right? It could vary um depending on maybe the position of objects within the game and several other factors, right? And the third architecture, which is in my opinion probably the most used one, is basically this basically just combines both of the two architectures that we talked about earlier. So depending on the situation of the game and the kind of logic behind the game, basically it could the time between each iteration could either be fixed or it could vary. So yeah, just a small code example. So you could, in this example, you are getting, it's basically following the steps that we've mentioned, right? You are getting a player's inputs, you are updating the game state based on the inputs, then you're rendering the game, then you sleep, then start over again. So now, next, another architecture, another design pattern that we are going to be speaking about is decoupling game logic from rendering, which is a pattern that basically helps you achieve better performance and flexibility in your game. Okay, so why is it important to decouple game logic from rendering? So basically, game logic and rendering are two different things, right? So there are some behind the scene code that represents what you see on the screen. So behind the screen um you have some particular information, right, that you are changing based on the user's action, right? So using the example of the video game that we have been speaking about, so you have your position, you have your speed. And in this sense, like when the user performs an action, you are updating this based on the user's action, right? So that is the game logic. But and on the other hand, basically what the user just sees on their screen is just the car moving, the car in a particular position. So that is rendering. And those are two different things, right? Because game logic is basically concerned with the rules of the game, the behavior of the game, how you change, how data is updated within the game, while rendering is mostly about how you actually display or render these games on the screen. And then when you decouple those, right, when you sort of like make these two concerns separate, what you do is you improve the performance and flexibility of your game. So basically, how can it be achieved, right? So a way that this can be achieved is that, so before we even speak about how it can be achieved, just to give like more background on um how helpful decoupling the two games can be, right? So let's assume analogy again, or let's use an analogy again. So let's assume that you are playing a game where let's say you are running in a forest, right? So in that kind of situation, what you see is the forest with the leaves, the color of the leaves and everything, right? And then on the other hand, which is rendering, right, which is the game rendering. And on the other hand, you have the logic, which is basically some behind the scene information on maybe how you move within the forest and everything. And basically what separating these two things does is that you could easily change, let's say, how your game looks without necessarily changing, affecting like how your game operates, if that makes sense, right? So let's assume that I want to change, maybe initially I was building my forest with the assumption that, oh, it's summer, right? And then maybe later on in the game I'm like, oh, I want to change the color of my leaves in the forest. I want to make it seem like they're falling. I want to make it look like it's fall, for example. So in that situation, you are basically changing the look of your game, but you are not necessarily changing, the logic behind the game. or the rules behind the game. So in that form of situation, having clear separation of your rendering and your a clear separation of your rendering and your logic is going to be helpful, because that means that in that situation, all you just need to do is go to the particular part of your code that focuses on the rendering, right? So you don't need to change anything that has to do with logic, and this is going to make development a lot easier for you, a lot more maintainable. So basically, how can it be achieved, right? So basically, the way it can be achieved is that you have a separate thread for the game logic, you have a separate thread for your game rendering. And basically, even this in of itself, having separate thread is going to even like improve the efficiency, the performance of your game, because that means like none of them need to wait for each other to perform their task. You can be updating the logic of your game, like regardless of what is currently being rendered on your screen, or to the user to see in your game, right? So basically, using a separate thread for your logic and your rendering is a way that you can achieve this decoupling mechanism. So another way that you could do it is that you could have like maybe a system that sort of pass message between the game logic and the rendering engine. So you could have um some way of passing information like between separate these two separate parts of the game, because even though they are separate, you still need them to work sort of together, right? You still need your rendering engine still needs to get some information about the particular state of the game, which is the game logic. So basically that is uh what you mean by having a system between them that basically passes the information between the two parts of your game. And then also you could have a component based system represent um to represent the game object. And this is, in a way, this is similar to the ECS that we talked about earlier, right? And where we have a component to represent the different data of your game, and then you bring together different components to actually represent objects within your game. And this is sort of like telling you how each of these game patterns are not necessarily like separate. They all of them sort of like work hand to hand with each other to give you like more maintainable code, more maintainable way of actually working within your game development process. So what are the benefits of decoupling game logic from rendering? So we've sort of touched briefly about some of the benefits earlier. So the first benefit is that it improves the performance of your game. So like I mentioned earlier, having like different threads for your logic, for your rendering, decoupling these two things essentially is going to help you improve performance, because each of them are able to run independently of each other. So you could be updating the logic of your game, that's like the state of your game, without having to worry about how the game looks to the user, right? And on the other hand as well, you could be changing like the position or the appearance of your game without necessarily like having to worry, like each having to worry about the logic, like what is going on behind the scene. So having like this clear separation of concerns is going to help like improve the performance of the game. The next thing is it's going to increase flexibility. So it would help you to make your game more flexible, because you are basically able to maybe add a new feature, add a new state to your game without even worrying much about changing the performance, changing the appearance of the game. And like I mentioned earlier, using the forest analogy, you could easily maybe add a new, I don't know, maybe a new tree to your forest without thinking much about, oh, how is this going to change how my player moves within the forest? Because in that situation, those two things are separated from each other, right? So and it is also going to help you easily debug your game, right? So if you are facing a situation where maybe the player is not, maybe the game is not, the logic is not changing as you want it to, right? So you could just focus on one thing, right? You are able to just focus on just the game logic part of it without necessarily touching the appearance part of it. And what that is going to do is it is going to help it easy for you to debug your games. So just another code example of that. So you could see in this example, you have different function. You have a function um, for updating your game. You have a different one for rendering the game, right? And then so each of them are basically separated from each other. And just to circle back to our earlier explanation of the game loop, so you can see that the game loop is getting the input, then you are updating the game logic, then you are rendering the game. So this sort of like separates like each of the concerns. So you have a function that is basically just concerned about how the game looks on the screen. I have one that is all it is basically concerned with is where your how your player moves within the game. So yeah. So now moving on to conclusion, just summarizing everything that we've spoken about today. So, what are the benefits of using these patterns and architectures? So, like I've mentioned earlier, it is going to improve the performance of the games. So, using well designed patterns within your games, using well defined architectures is going to help you, it's going to help users, play your games in a much easier manner, in a much faster and scalable manner. It is going to increase the flexibility of your game. So that means that your games becomes more versatile. You are able to add new things easily to your game. You are able to easily maintain your game, and it is also going to improve your development process because it will be by using well designed patterns and architectures, right, it is easier for you to even understand what is going on within your game, and it is going to in the long run make it easier for you to um add more things to your game easily, extend your game as you wish. So what have we learned? We have learned about the different game development patterns and architectures. We've spoken about how to use these architectures to create better games, and we've also spoken about the importance of decoupling your game logic from your game rendering. So thank you so much for listening to this talk. If you want to connect with me or basically discuss more about the talk, any opinion that you have at all, you can reach me on any of the social media platforms. Yeah, so thank you so much for listening.
All right. What an amazing talk. Thank you so much. All right. Olayinka, please join me on the stage. Welcome, welcome.
Hi.
So nice to meet you. How are you?
Hi, so nice to meet you too. I'm fine. Thank you so much. How are you too?
Oh, awesome. Doing fantastic. Loved your talk. And let's talk about the results of our poll question. The question was about how many hours per week do you play games? So how about you, Olayinka? How many hours per week do you think that you probably play games?
I think 1 to 3 hours.
3 hours? Yep.
Yeah.
Ranges for me quite a bit. Yeah. Some weeks I'm just too busy. But then once in a while I have like a vacation or something, and then I'll like really cranks up. It becomes like a part-time job, full-time job. So cool. Thanks everybody for your answers. You can always submit questions and answers at slido.com, code 0928. So let's jump into the question.
All right, Matt, please promote our JS Game Dev Summit hashtag.
Yeah. So everybody, have you been tweeting about the conference? That's hashtag JS Game Dev Summit. Posting selfies or other great photos? Use that hashtag. Remember that after the talks, we will pick 2 random winners for the Git Nation Multipass, which comes with access to a whole batch of JS conferences, including in-person access to React Day Berlin from the Git Nation team. Post your tweets and photos with the hashtag JS Game Dev Summit.
All right. Now we have our next talk. Ronan will be talking about unleashing next-gen 3D web experiences with Babylon JS 6.0. And about Ronan, he's a JavaScript and TypeScript developer, maybe a web developer, you call him. And he's currently working at Microsoft as Babylon JS's web tech lead, and he's one of its core contributors with emphasis on WebXR and the engine's build system. He has a passion for open source. He constantly contributes to Babylon JS and various other open source projects. He lives in Berlin, Germany, and there he can find joy in playing the guitar and exploring Berlin's forest with his family and dog. That's cute. So before we get to the talk, he has a question for everyone. Ronan is interested in knowing that if you have used Babylon JS before. So please go to Slido and answer his question. And now, Ronan, the stage is yours.
Hello everyone, my name is Ranan and I'll be presenting Babylon JS, the open source 3D rendering engine. First, a bit about me. I am a software developer at Microsoft. I am Babylon JS's web tech lead and a core contributor since roughly 2014. I am directly responsible for Babylon's infrastructure, its build system, the WebXR abstraction, and a few other features along the way. But let's talk Babylon. Our goal at Babylon JS is to create the most powerful, beautiful, simple, and open web rendering engine. We want to provide any developer, designer, and hobbyist all of the tools needed to create GPU-accelerated 3D experiences and games on the web without the need to deeply understand 3D rendering, while allowing experienced developers the tools to get the most out of these APIs. So Babylon is a fully featured web rendering engine. It is written in TypeScript, transpiled to JavaScript, and it is built on top of open web standards. Standards like WebGL and WebGPU for rendering, web audio and video for media consumptions, and other standards like WebXR, WebRTC, WebAssembly. In general, every API that starts with web, we want to support it. Babylon is always backward compatible, which is a guiding principle for the team when developing new features or modifying older ones. Code written in Babylon 3 will still work in Babylon 6, 7, or 10. The framework is roughly 10 years old and is being used in production websites throughout the web. Apart from our core package, we offer different packages like loaders, serializers, materials, UI, and others, including all of our editors and tools. Everything is open source and we publish them on both NPM and on our CDN. Out of the box, we have full support for WebGL 1 and 2, WebGPU. We have Canvas accelerated UI, advanced material system, physics integration, WebXR abstraction, device input system, and many, many other features. You can visit our website and doc page to see a full list of the features. Babylon has a set of powerful tools to allow you to make the best out of the engine. The first tool is the Playground. The Playground is a side-by-side code editor and lets you see your scene you're working right in your browser. It is based on Monaco, which is the editor used in, among other, VS Code. You can write code in either JavaScript or TypeScript, and you have full access to all of Babylon's features and published packages. The Playground allows you to save your code, share it with others, and even download your scene and host it yourself. The playground is available at playground.babylonjs.com and is a perfect place to get you started with the engine and understand its capabilities. It includes many different examples. The second tool is the inspector. The inspector is a debugging tool for your scene. You can enable and disable features using a very simple UI. See or edit your scene graph, check your meshes, your materials, your textures in your scene, and transform them to your needs. The inspector can be enabled on any Babylon scene using just a few lines of code, and it is integrated in the playground to simplify debugging your playground scenes. The third tool I want to talk about is the Node Material Editor. Node Material Editor, or NME, allows you to create shader materials using a set of blocks available in our core library. Using a very intuitive UI, you can create materials, save them as JSON files, or directly on our free snippet server, and add them to your scene using a single line of code. The last tool I want to show here is the UI editor. This is the tool that you're seeing right now. The UI editor allows you to create 2D accelerated UI for your Babylon experience. Using all of the features of our powerful UI library, you can add, remove, and transform different types of UI elements, and just like the enemy, save them as downloadable JSON or on our snippet server, and then use them directly in your scene. Using that couldn't be simpler. Simply parse the JSON or provide the snippet ID to integrate the UI in your scene and hook up any callbacks you need by using Babylon's simple device input API. All of those tools, as you can see, are integrated in the playground. So if you add a node material or a UI, you can edit them directly in the playground. I want to shortly mention Babylon Native. Babylon Native brings the power of Babylon Engine to native platforms. As a developer, you can reuse the same code you use for web experiences in native environments like Android, iOS, Windows, and others. If you want to know more about Babylon Native and Babylon React Native, you can visit GitHub or our documentation page. That was a general overview of Babylon.js. Now I want to dive into the new features added in our latest major release, Babylon.js 6.0, that was released last April. Babylon 6.0 was a major milestone for the team as it brought a lot of improvements and new APIs to our community of developers. The most remarkable feature we added in 6.0 was the integration of the Havoc physics engine. Havoc is a world-known physics engine used in many AAA games. Together with the Havoc team, we have worked to bring Havoc to the web using WebAssembly. Up to 6.0, we had support for Emo.js, Canon, and Oimo physics engine using a single unified API. For Havoc, we have also introduced a new version of our physics API that simplifies creating a highly performant physics experience on Babylon.js. The Physics API 2.0 allows us to add new and exciting features to our physics capabilities like advanced physics raycasting, better joint support, full mesh and convex hull support, and a lot more, while making the engine perform 20 times faster and more than the older API. We've also released a game called the Playroom to show the new capabilities. You can visit the game at theplayroom.babylonjs.com. So let me jump to the playground and see some physics example. The first example I want to show is the stress test that we have implemented. You can see that when using Emo.js, that we were right now seeing with a large number of objects, Emo.js is a bit choked, and on my machine it works roughly in 6 frames per second. Now, let's see what happens when we switch to Havoc. When we switch to Havoc, you can see that the rendering stays at 60 frames per second and even provides a larger potential frames per second. This is the same scene using our old physics API with Emo and the new physics API in Havoc. Even when we're using a height map as a ground, Havoc still maintains its high performance. So let's open a second example that I want to show, which is our physics helper functions, which are a part of our core physics support. The helpers allow you to create special physics effects with ease. We have effects like vortex, updraft, gravitational field, and radial explosion. They can be triggered using a single function call on any physics-enabled scene. In this example, you can see exactly how to use this function. The code is available on the right. You can also enable the debug viewer if you want to see exactly how the physics engine is working. You can see how performance would improve if you're using instances or an aggregate. The last example I want to show is the constraints in Havoc. You can use them directly using our physics API, connecting two or more physics body to one another. All of these examples are on our playground, which also include many other demos. You can find a lot more on our documentation page. Fluid rendering was a feature our community has asked for quite some time. In Babylon 6.0, we have added screen space fluid rendering. Enabling this feature requires just a single line of code. You can enable it on the scene, and afterwards you can render our particle or GPU particle system using the fluid renderer. The feature is fully documented, including many different demos, and you can get started right away. You can see here 2 demos that are available in our documentation page. Until Babylon 6.0, we have offered screen space reflections, or SSR, using a post process. It was working well, but was not highly performant, and a little hard to fully configure. As part of making Babylon more powerful and simple to use, we have deprecated the post process and have added an SSR rendering pipeline that simplified adding screen space reflections to your scene. It supports both WebGL2 and WebGPU and can be enabled using just a few lines of code. On top of that, SSR has a debug mode that allows you to see how the SSR rendering pipeline is seeing the scene and help you understand how it works. Enabling this mode is as simple as turning on a flag in the rendering pipeline. This demo is also available on our playground and in our documentation page. Babylon has added WebGPU support in Babylon 5.0 already, with support that was improved immensely in Babylon 6.0. It is fully backward compatible, always making sure that even if the WebGPU API itself changed, and it does, Babylon still maintains the same API, and it helps you upgrade to a better, more performant rendering engine. We have also full support for compute shaders that allow you to fully utilize GPU in your scene. WebGPU now comes with different snapshot modes that can accelerate rendering your scene depending on your use of the engine. WebGPU lives along WebGL2, so you as a developer can decide if you utilize the stable WebGL2 that is available all over, or the newer, more performant WebGPU. We make sure every new feature added to Babylon is tested on both WebGL and WebGPU. All features are fully documented, and the WebGPU engine is also integrated in our playground if you want to experiment with that right now. Another feature that we added as part of our scene optimization suite was the performance priority modes. Using this simple tool, you can optimize the rendering process of your scene. The default mode, the one you see right now, is the one you get out of the box. It makes no assumptions regarding your scene and will always work correctly. The 2 other modes, intermediate and aggressive, will make certain assumptions regarding your scene and will enable or disable certain features that might not be needed. Depending on the features that you use or don't use, you can set the selected priority mode using a single function call to get a rendering boost for your Babylon experience. In this example, rendering 2,500 spheres with 50 different materials, you can see how moving to the aggressive mode, the one that we're seeing right now, has improved rendering by more than 50%. An exciting and, in my opinion, underrated feature that we added in 6.0 is the accessible screen reader support. Simply put, it is a way to generate an HTML tree from your scene. The HTML tree can be read by a screen reader, making your scene accessible for people with disabilities. It fully supports our 2D UI as well. Every HTML element is fully configured using a JS object located on the nodes or UI elements in your scene, so you can decide how the screen reader understands your scene. It also supports keyboard event using our action manager. So, for example, you can use a tab to navigate the scene and have the screen reader read what you're currently pointing at, and then select it with any key that you want, for example, an enter or a space key. Babylon has had mesh decal support for a long time now. Mesh decals add a mesh on top of another mesh to paint decals in the right place. However, adding them might hurt performance to your scene if you add too many of them. To improve performance when using decals, we have added texture decal support in 6.0. Using texture decals, you're only adding a texture on top of the existing material to render the decals. The result is faster to generate and faster to render. This example that you see is in our documentation page and is running in our playground. So Babylon 6.0 was an exciting release for the team. On top of the features I presented, we have fixed many different bugs and have added hundreds of improvements and additions to our existing API. If you want a full list of the changes, you can change our changelog in the GitHub repository. And now we are marching forward developing the upcoming major version 7.0. It has a growing list of new features. Let me share just a few of them with you right now. The first feature is a whole new editor that was added to our arsenal, the Node Geometry Editor. Inspired by Blender's Geometry node, the NGE allows you to procedurally generate meshes for your Babylon experience using a very simple UI by adding different types of blocks to a unified graph, very similar to the way NME works for materials. Using a procedural building process instead of exporting a mesh from the 3D editor can improve download, render, and startup time, and in general improve your scene's performance. The initial version of NGE was already deployed, and it is available on NPM, RCDN, and also in our playground. If you want to visit the standalone version, the one that we saw right before, you can go to nge.babylonjs.com and already start experimenting with it. Another feature that was requested by our community for quite some time is what we like to call the flow graph. The flow graph is a way to programmatically introduce interactivity to your scene, kind of like an advanced action manager. Using predefined building blocks, you will be able to define triggers and actions in your scene using the same simple and known UI the Node Material and the Node Geometry Editor are using. The flow graph will be fully compatible with GLTF's new interactivity extension, which is currently in draft mode. It is a work in progress, and if you want to follow it and see what we're doing, you can follow our GitHub repository and the issue existing there. Another new feature coming to 7.0 is the experimental support for pure ES modules. Babylon is currently packaged in two different ways, UMD, so ES6 and UMD, and both of them have side effects. Having side effects mean that tree shaking is not fully supported and require a bit of work to achieve, and with UMD, tree shaking is not even possible. The idea behind our ESM support is to provide a function-based API with no side effects that will allow the developer to only use what they need for the experience. This way, the developer is only using the minimum they need to render their experience, minimizing their package size and download size, and avoiding side effects. It will also compile with the latest JavaScript version to allow us, the Babylon developers, and devs using Babylon to use modern JavaScript. This is still a work in progress. We will first provide a revamped API to our base components like the engines and the scene. The current packages, the UMD and the ES6 packages, will continue being published, of course, and they will not be converted to ESM. What else is coming to Babylon 7.0? A lot. We have a long list of features we want to implement for 7, and we can't wait for the community to try them out. from new WebXR features to revamped audio engine, improved device input system, new physics capabilities, and of course community-driven features that are already developed like the USD-Z serializer and the greased line material. Babylon 7.0 will be another exciting release for us and for our community as well. Babylon 7.0 is coming next year, roughly around April. Before I'm done, I want to share some links to get you started with Babylon.js. First, our mono repo on GitHub holds all of our code and issues for 7.0 and future releases, including all of our tools. Our main site, babylonjs.com, can give you a wonderful overview of the engine and its capabilities. If you have any questions about Babylon, I can only recommend you to join our forum, forum.babylonjs.com, and be a part of our super friendly community. The team is there daily to answer your questions as well. And the best way to get started with Babylon is our documentation page that has many tutorials and code examples integrated in the documentation page itself. And with that, I want to thank you so much for listening. I hope you enjoyed this presentation as much as I enjoyed making it and giving it. If you have any question whatsoever, stay afterwards for the Q&A or contact me or the rest of the team on either our forum or on Twitter. Thank you so much.
All right, what an amazing talk. I would like to thank Ranon and ask him to join me on stage. Hello, nice to meet you. I think they are having internet issues. Okay. I think I'm going to ask Matt to join me. Hi, Matt. I think we're
Hello.
having internet connections with Ranon again.
That happens.
Yeah, that does
We
happen.
will survive.
Yeah. So I'm going to
That was a
ask
cool
you a
talk.
couple of questions, actually,
All
Matt.
right. I
Yeah.
love questions.
Yeah. Okay. I want to ask if you worked with Babylon.js or Tree.js before?
Babylon.js, I have not. I've definitely heard of it. 3JS, I have, not too much, but it's hard to ignore 3JS's just massive impact on pushing like 3D on the web forward.
Yeah.
So I think that if you're the kind of person like I am, where if there's a new cool web tech, you're probably just gonna experiment with it eventually. So that's kind of where I was at with 3JS. But I found it really easy to like load up 3D models and just make cool effects. So I haven't used Babylon, but I have used 3JS.
Oh, that's cool. I used 3JS for a bit, and not so much, but I would really like to, after the talk, I would actually like to experiment with Babylon.js to see what it is.
Fun times.
Yeah.
Sorry.
Actually, we have Ranon back.
Hi, everyone.
Thank you, Tom. Thank you, Matt.
My
Thank you.
internet decided
Hi.
to stop working exactly at the right time. I'm so sorry.
Oh, it's okay. It's okay. All right, so we have the answers to your poll question. Have you used Babylon.js before? And a lot of people said that they have heard of it, but they haven't used it. Yeah.
First,
So
I hope that this talk will convince them to try it out. I think the fact that Babylon is also web and web only maybe will. I know we are JS devs, but we want to usually develop games for a few more platforms. But I believe that targeting web, if you want to target web, use a real web engine, and Babylon is a perfect engine for that. So
yeah,
if you
actually,
haven't tried, try it.
Yeah, actually, I'm going to try it after this. Yeah, I'm very interested in that. So, Ranon, we have a couple of, actually, a lot of. much. I'm going to hand it over to Matt to continue.
All right. Thanks, Sahar. So now let's hear it for our gold sponsor. Make some noise for Focus Reactive. Woo! Let's hear it. Focus Reactive is a Next.js, headless CMS, and e-commerce expert agency. They partner with Vercel, Shopify, Storyblock, and Sanity.io to deliver quality software with a focus on scalability, performance, and great user experience. If you need expert consultancy for the modern web, head on over to focusreactive.com. Oh, wait, listen. Do you hear the distant sound of thunder? That must mean it's time for our lightning talks. This is going to be fun and fast, so prepare yourself. Florin, Ilya, and Adrian, the stage is yours.
Hey everyone, my name is Florin and I'll talk today about boosting the performance of your WebGL Unity games. So a little bit about me, I'm a product engineer at Crazy Games. I'm also a game developer. You can see a couple of the games I created here. I mostly work with Unity, but I also do have some simple vanilla JS games. About Crazy Games, we're one of the biggest gaming platforms with more than 5,000 games. We work with more than 700 developers and we also have 20 million of unique players. So yeah, let's start with the Unity web issues that you may encounter when building for the web. So there is the bundle size. It affects how fast your game loads, the memory usage, the RAM that basically your game uses when it runs, and the runtime performance. And why it's important to keep runtime memory usage low? Well, in the browser, Unity uses a memory heap to store the game data. And let's say you load a new scene, new textures need to be loaded, the browser may have to increase the heap size. And if the browser fails to allocate more memory to increase the heap size, you'll get this ugly pop-up that just crashes your game. About the code performance, I won't talk about it here, so Oz already gave an excellent presentation about it. It's called Detect and Avoid Common Performance and Memory Issues in Unity WebGL Builds, and I encourage everyone checks it. About Brotli and JZip, so these two are two different compression formats for the build in Unity. First of all, don't ever launch uncompressed builds because they take around 11 megabytes. The JZip, the default one, takes a little bit more space than the Brotli, so that's why we usually recommend the developers to pick the Brotli one, because you can see the difference. It may be quite small in an empty project, but when your game gets bigger, this difference will only get bigger. So yeah, usually stick with the Brotli one. Although it takes a little bit more time to compress, that's worth it. About the exception support, so when you build a game for the web, you can pick the known exception support. This is more performant, but you can't use try catch anymore in your code. If you know that you have to use try catch somewhere, pick the explicitly thrown exceptions only, which I think is also the default. And usually, you should avoid the full ones, except if you are debugging the game, because they negatively affect the bundle size and the performance of your game. I'd also like to talk about the texture compression format, which you can pick. DXT is the default one, and this one is better for the desktop browsers. There is also STC that's better for mobile browsers and some Chromebooks. And if you pick the proper compression format, the textures don't have to be decompressed in memory, and the game will use less runtime memory. You can see here in this small memory snapshot, we have a build with 6 textures, all of them quite big. And if they are decompressed in memory, they'll take around 75 megabytes. If they stay compressed, they take around 10 megabytes. So basically, you manage to save around 65 megabytes of runtime memory. That's quite a lot on a mobile device. We tried to experiment this also with a couple of our games. Sadly, we only got some negligible load rate and load time improvements. And how we did it, we have to basically 2 separate builds, and we either load the DXT one on all platforms, or we smartly load this one to test on the necessary platform. And yeah, as we said, we didn't get any considerable improvements, but still, if you have, for example, a game that you launch only for mobile devices, consider to use this one, for example. Or you can check on Unity documentation, how to load 2 separate builds, how we did with this experiment. About the texture options, so pay attention at max size here, because you should keep this as low as possible on WebGL to reduce the final build size. If you reduce it, this will also reduce the texture size in the final build. You can also consider using crunch compression. It will help decrease also the bundle size, but it works only for these 2 texture compression formats, DXT and ATC. It may take a little bit more time to build the game because the compression time will be increased, but yeah, the decompression is pretty fast when you start the game. About the models, just in case you enable this one, keep in mind that now the model needs to be kept in the runtime memory usage, so it's better to keep it disabled. I think it's by default, it's also disabled. And also check if you can increase the mesh compression to high, for example, because you may have, let's say, a mountain in the distance that doesn't need to be high quality. About the audio, if you pick compressed in memory, that's usually good for background audio. It reduces the runtime memory usage, and background audios are usually some music loops that take quite a lot of memory. But this may reduce a little bit the latency and cause some imprecise audio play. Decompress and load, it's better for audio effects because you can keep them decompressed in memory. They usually don't take so much space, but they need to be precise when they're played. Also consider lowering the quality for the background audio because this may considerably reduce the audio size in the final build. Our optimization tool that you can grab on GitHub or Unity Asset Store, and it also comes in our SDK, offers you all these tabs. They'll help you optimize your assets. And it also offers build logs analyzers. For those who don't know, Unity usually generates a build log when you build a project. And it's an ugly txt file, log file. But this tool will beautify it a little bit and show you in a more readable way all the assets. And you can have a final look at all the assets that ended up in your final build. About asset bundles and other samples, consider using them because they help decrease the initial load size. How they work, they basically extract the textures, for example audio, some objects in a separate file that gets loaded only when it's needed. And you can do it with asset bundles, which is low level. You just fetch the file and extract the assets from it. But Unity now has another samples package that builds on top of asset bundles, and it's much easier to use. You can see here an example of a game that uses addressables, and the initial build size, the build folder, it's around 17 megabytes. But the streaming assets folder, all these files will be loaded later when needed. It's around 16 megabytes. So the developer managed to save around 16 megabytes from the initial game load. I can't finish, of course, this presentation without talking a little bit about the integrated profiler tool, which I think everyone should use to spot the performance issues and the memory issues. But for memory issues, if you want a little bit more detailed overview, there is a new package from Unity called Memory Profiler tool. It will help you capture snapshots of your running game. It can also connect directly to WebGL, and then it helps you analyze the textures, for example, of the audio in the runtime memory. So that was all from my side. Thank you for listening to it, and don't hesitate to check our documentation where we have more tips for Unity. And you can also contact us at developerrelations@crazygames.com. And we are looking forward to seeing your games on crazygames.com. Bye.
Hello. My name is Ilya Chernevsky, and I work as a web developer at Evolution Company and create front-end of games. Today, I want to tell you about my experience of using Canvas element in games and web applications. First of all, to increase performance. Let's look at this element in one of Evolution games. It contains approximately 4,000 DOM elements. Basically, these are SVG elements with their own styles, attributes, classes, sizes, positioning, etc. You may say that 4,000 is not so much. Perhaps. But you know what could be better? I think better is to have only one DOM element. Firstly, what is Canvas? And its core Canvas is a rectangular area where we can dynamically create graphics using JavaScript. Drawing on Canvas provides a low-level way to display graphics in the browser. DOM operations in the browser are considered quite slow. This is why, for example, React team developed virtual DOM concept to minimize handling DOM elements. Let's look at the advantages and disadvantages of Canvas. Let's start with the advantages. First of all, and I think most importantly, its performance and speed. We have just only one DOM element. Second is memory saving, since there is no need to store information about a large number of DOM elements. and control. Developer can control every pixel in the drawing area. Now let's look at the existing disadvantages of this approach. One of the most obvious is animations. They are more difficult to implement. Of course, we can't use animation and transition property from CSS. In the case of DOM elements, for example, when they are moved, the browser itself erases the old object and draws the new one in a new place. And in the case of Canvas, developer forced to independently draw each frame using request animation frame function from browser web API. And second con is complexity. In general, DOM elements are easier to manipulate than pixels, and using Canvas API is more difficult. In the case of DOM elements, browser does part of the work for us. And finally, features of working with displays with device pixel ratio, more than one. For example, when we work with smartphones, you have to keep an eye on the dimensions of the canvas, and sometimes this can lead to unexpected artifacts. And in general, you're forced to think more about other features of Canvas that may not be immediately obvious. When people talk about Canvas, they most often mean the Canvas API and the Canvas rendering context 2D interface. This is the simplest and low-level way to render in the browser. However, if you want to use the all power of GPU, then you should consider using WebGL. WebGL API is used with the same HTML canvas element, but for rendering it's used a different drawing context, WebGL rendering context, and also use a different API, WebGL API. So with one HTML element canvas, we can use two different APIs, Canvas API and WebGL API. Let's compare these two ways. Canvas API can use CPU or GPU rendering. The browser itself decides this according to its internal logic. However, based on its internal algorithms, if browser decides to use CPU, in this case, graphics hardware acceleration will not be used because it's physically located on the graphics card. However, it's not obligatory that using hardware acceleration will necessarily lead to increased performance. Often it will, but not always. WebGL API uses only GPU and also hardware acceleration if the graphics card has it, which is almost does. This is almost always fastened because the GPU is optimized for graphics and this releases CPU resources to run the rest of the application. So it's also has to be mentioned that complexity of using both of these technologies is different. While Canvas API is less difficult to use and can be used without external libraries, for example, WebGL is much more difficult to use and has a much higher entrance threshold. It's more often used with third-party libraries, such as Babylon.js, for example, or 3.js. Unlike HTML and SVG elements, the image on canvas is raster. Therefore, for example, when we zoom in canvas element, we will see that image quality has become worse. Also, text written on canvas will be blurry when zoomed in, and to improve quality, we will be forced to re-render. In conclusion, I want to say that Canvas is modern, low-level, high-performance element. Using it in your applications can significantly improve performance. However, it's important to understand that complexity and cost of development will also increase. It's especially true when your applications has animations. Yeah. Therefore, it's important to evaluate all of these factors and make the right decision. Thank you for your attention.
Hi everybody, my name is Adrian Herbez, and today we're going to be talking about creating custom CAD tools on the web with Three.js. I'm a web developer and a game developer, and I also make toys, 3D printed stuff mainly for action figures. As such, I've used a lot of 3D tools over the years, and I generally love them all, except they're really complicated. So I think you should make some new ones. Now why would you want to do that? There's a lot of reasons, but the most significant ones to me are that you can make truly novice-friendly tools, and you can make tools that are great for user-generated content. It's also not as hard as you might think. So why make a web-based tool? Well, because the web's the best platform. It's easy to distribute, it's inherently cross-platform, and again, this all goes to being very approachable for novices. So here's an example of the kind of thing I mean. I wanted to make it easy to make Reeblies, sci-fi panels of stuff, and so I made this tool that runs in a browser, and instead of moving points or vertices or polygons around, you just draw a rectangle on the surface of a base shape, and you can add a parametric feature of a few different types. You can add extrusions, you can add arrays of buttons, you can add handles of the type you might see on rack-mounted equipment, and you can add dials. And none of this requires any conventional 3D modeling skills, so it's very approachable. And I made this with Three.js. Three.js is a fantastic library. It's a wrapper around WebGL. It's got a lot of great qualities. It's been around for about 13 years, so it has a really rich ecosystem. It works well with React and other frameworks, and I, at least personally, feel it has a great level of abstraction. So today we're going to make a cube, and we're going to take this sort of a slightly roundabout way to get there, but in doing so, we'll learn everything we need to know to make custom and parametric geometry of your own. But before that, there is a little bit of boilerplate. So I know this code is probably too small to see. I'll have a link to a GitHub repo at the end, but what I want to impress upon you is this is all that you need to set up a scene in Three.js. There's only about 30 lines here. It's all very straightforward. So having gotten that out of the way, let's talk about geometry. So geometry can contain a lot of data, but the two most important types are vertices, so points that are positioned in 3D space, and then faces, surfaces that link those points together. There's a lot of other stuff that we won't have time to talk about today, but with vertices and faces, we can make geometry. So here's a cube. Let's take away its skin, and we'll see that we have 8 points. So let's start by giving those points an ordering. So we'll just give them some numbers, 0 to 7, to lay them out in some order. And then once we've done that, let's specify where they are in space. So to keep it simple, I'm just using negative 1s and 1s. That'll give us a 2-unit cube centered at the origin, which is great. Great. So having done all that, we can specify our vertex data. So to do that, I'm just going to set up an array, and I'm going to push numbers into it for the x, y, and z coordinates of each vertex. Note that this is a one-dimensional array. I'm not pushing a full set of a triplet at a time, and this just ends up being one-dimensional, which is important later. So that's our vertex data. Now we're ready to set up our faces. So faces are specified by giving a sequence of vertices in order. So what we do is, instead of having actual data, we just reference the data that already exists in the vertex list. So, and the order in which we specify the vertices matters a lot. So in 3D graphics, a big part of getting things to be performant is to not draw things you don't need to see. And one of the ways that we do that is by only drawing one side of faces by default. So faces only really exist from one direction. And the way we specify which direction that is the order in which we specify the vertices. So it's important that we specify our vertices in counterclockwise order. So this blue triangle, for example, involves the vertices 0, 4, and 3, but if we specify them in 0, 4, 3 order, that would be clockwise. And this face would end up pointed into the cube instead of towards the outside of the cube, and we'd end up not seeing anything and wondering why nothing's rendering, which is a very standard state in 3D graphics. So instead, we need to make sure we specify them in counterclockwise order, like 3, 4, 0. So having said that, we can specify our face data. So we start again with just an array, and for each triangle, we enter 3 integers that are indices into the vertex data. So we just do that once for every triangle we have, and with that, we're ready to actually set up some geometry in Three.js. So objects in Three.js always consist of geometry and a material. So let's set that up. So we're going to use a mesh basic material. There's a lot of different material types in Three.js. This is the simplest one, but they all work in a similar way in that you make them and pass in an object with parameters. So in this case, we're just passing in a color of bright green. And for geometry, we're going to use a buffer geometry. Now, there is also just a vanilla geometry in Three.js, but that's a little outdated and it's a little less efficient. So I want all y'all to be set up really well for the future. And so we're going to use a buffer geometry, which means we have to fill buffers. So what a buffer is it's typed binary data that can be used to efficiently move data from the CPU to the GPU. So for vertices, we want to use float32 as our data type, because we're talking about floating point numbers representing the position in three-dimensional space. So we first make a float32 array from our vertices, then we make a new buffer attribute. And this may look a little cryptic. We pass in the vertex data, right? But then we pass in this 3. And what that has to do with is that buffer attributes are always on a per vertex basis. So as we pass in data, we have to specify how many numbers or how fast we consume data per vertex. So in this case, it's position data. So we have an X, a Y, and a Z. So we have 3 numbers per vertex. So we pass in 3. Now that we've got the buffer attribute, we set the attribute as the position. And now we're ready for the indices, which is similar, except we use an unsigned int instead. And when we make the buffer attribute, this is 1 index per vertex, so we pass in 1. And then we set index, and with that, we have geometry. But it's a little hard to see because it's all just bright green. So we can fix that really quick with normals. So what's a normal? A normal is a vector that points away from a surface. You can have vertex normals like on the left or face normals like on the right, and you can pass this in as buffer attributes, but we'll do it a little easier, and then we'll just have Three.js compute them for us with compute vertex normals. And once we've done that, we can use a mesh normal material, which works by taking each vector. A normal is a vector with an x, y, and z component. And if we interpret the x, y, and z as an RGB value, we get colors. And with those colors, we can get something that we can see and get a lot better detail of the geometry that we've made. And that's it. Thanks so much.
All right. Well, thank you, gentlemen, for those amazing lightning talks. If you have questions for our speakers, head on over to Discord in the Pixel Track channel and ask away.
All right. It has been an amazing experience so far. We've met some great people and we've heard some great talks, but we all need to take a short break and come back with more energy. So, because we have so many amazing talks coming up. See you after the break.
Welcome back to the Pixel Track here at JS GameDev Summit. I hope you've recharged your batteries, maybe get a coffee if you need it, and are ready for a new block of great talks. Before we get started, let's hear it for our gold sponsor. Make some noise for Evolution. Let's hear it. Check out their award-winning digital entertainment products and services with an ever-expanding lineup of product brands, including Evolution Live, NetEnt, Red Tiger, Azuki, Big Time Gaming, No Limit City, and DigiWheel. To learn more, head on over to evolutioneng.com.
All right, and please do not forget to ask your questions to the speakers, and we'll ask them to the speaker after the talk. And now we have Frank. Frank Force has worked in games industry for over 2 decades and has also released many games and tools on the site. To his count, there are over 50 releases. Wow. With source code available for most, you can check out a full list of everything he has released. Frank currently works as an independent developer in Austin, Texas, but in the past he has worked at Rooster Teeth Games, Certain Affinity, Lightbox, Volition, Midway Games, and Hypnotics. And he's going to talk about JavaScript Hikes, my adventures in tiny coding. And before we get to the talk, I want to ask a question. So Frank asked, what do you perceive as the biggest challenge in writing tiny code? Please go to Slido and answer his question. And now, Frank, please, the stage is yours.
Hi everyone, welcome to JavaScript Haikus, a talk all about my adventures in writing super tiny JavaScript programs. First, a little about myself. My name is Frank Force. I have a bachelor's in computer science, and I have over 20 years working in the video game industry all across the United States, some games that maybe you've played. Right now, I'm focused on indie game dev and creating generative art. Here are some of the games I made, all with JavaScript. And I also do generative art, which again is made with JavaScript. But today we're going to be focused on these super tiny tweet-sized programs. I made over 1,000 of them, and I want to share my secrets with you today. Let's talk about tiny code. So what is tiny code? Shakespeare said brevity is the soul of wit. And that's kind of what tiny code is, but for code instead of the language. There's a lot of different ways to describe tiny code. You can call it size coding, code golf, or just minifying. But ultimately, the goal is to create cool art, music, or other types of effects, and create it with very small, minimal amount of code while you're having fun. Now, this all started with the demo scene in the early 80s. Maybe you heard of it. It's kind of a computer art subculture where people make demos that are composed of graphics and music, and they often run on older computers. They can be anywhere from 64 kilobytes down to even below 256 bytes. But those are using bytecode, so they're starting to slowly embrace languages like JavaScript. Code golf is kind of the heart of tiny coding, and it's about using programming tricks to save space. So, for example, you'll squish your code down by removing white space, making variables single letters, not using ifs, and just not using functions, and kind of fighting for every single byte you could possibly get to squeeze everything down. JavaScript is great for this kind of thing because you can use a live editor. It's a web-based tool where you can type in code and see it happen and execute right away in real time. It's got instantaneous feedback, and it's a very visual way of programming. So I really love using a live editor for this kind of thing. You can even capture GIFs and images with it, and it has some tools to help debug and save and load your code to make it easy to iterate with. There's a couple different ways you can share tiny code. You can submit it to a demo party. There are also websites that you can share your code on, such as ShaderToy or Twitter.net, which we're going to be talking about today. What is Twitter? Twitter.net is a place where you can share 140 character JavaScript demos. It was created in 2016 and currently has over 20,000 tweets. The website itself is open source, and we're working on a new beta version that has some advanced features that I'll also be showing today. So the basics of Twitter is when you start a new tweet, you'll be presented with this default bit of code that draws 9 lines on the screen and has them moving back and forth. Here's the code for that. It also will automatically set up a canvas and a loop for you so that the animation is really easy to get working. There are a couple functions that are set up automatically for sine, cosine, tangent, and to get an RGBA color. So for example, if you want to minify the default Twitter program, you start out with the one on the left, then you start making optimizations and minifications by removing the comments and squishing it down. Then you can make it even smaller by making some concessions, which change the output a tiny bit, but not in a very noticeable way. Like, for example, changing the gap between those rectangles from 100 to 99. That saves a whole byte of space, and saving those bytes really adds up. Twitter can also be run standalone. So if you wanted to make, say, an HTML file that is able to execute a tweet, it would look something like this. The tweet code is just that little bit in the center there. Everything else is setting up the Twitter interface in a canvas. Just a really minimal amount of code necessary to run one of these. It's pretty much vanilla JavaScript. We've done all kinds of fun remixes of the default tweet. Here are some of my favorite community remixes. I've also done a couple myself, all using this same kind of concept and exploring what we can do with just those 9 vertical lines. Something you might want to be aware of when using Twitter is that Twitter uses 140 characters, and each one of those characters can hold multiple bytes. We found a way to store 2 bytes in each one of these Unicode characters, and with the decoder also included, we're able to fit up to 194 bytes in a single tweet. You can imagine the way that works is you have these Astral Unicode characters where they hold 4 bytes, but 2 of the bytes can be whatever you want. So the way that uncompression works is it calls escape on the Unicode character, removes the unnecessary stuff, then unescapes it and evaluates what's left over. And it's really allowed us to push the limit of what's possible in a tweet. You can use a similar technique to pack image data, and I've experimented with that a little bit to create the Mona Duitza, a Mona Lisa fit in a tweet, and even a self-portrait, and all kinds of old school graphics, bitmap art. It's pretty fun to experiment with. Tiny graphics. Most of what we'll be doing is using the 2D Canvas API to draw geometric shapes, text and emojis. We can set the color in alpha and use features like shadow and shadow blur to do special effects. It's even possible to draw 1 pixel at a time to create super high definition raster graphics. So for example, the kind of functions we'll use are like fill rect, arc, setting fill style, drawing lines, that type of thing. And nearly everything is done using these very small set of functions. There are other options also you can use for graphics, such as HTML. CSS has some neat things you can do, and even making SVGs. And I managed to plot one of my tweets that uses an SVG. It was kind of a fun experiment. Random numbers are really key to this whole kind of art creation. And there is a math random, of course, which you can use to get random numbers between 0 and 1. But sometimes you need something like a seeded random number. And you can accomplish that with like doing sine of a value squared. Is a simple way to get a type of random result. And there's all different types of things you can do to get randomish numbers, like using the mod operator. And you can even create a kind of fractal noise, Perlin noise type of effect with this too. There are so many different types of algorithms that are possible in this space. It's kind of incredible. Really anything is possible, and that's what I'm going to be showing you today. You can even make tiny games that fit in this space. I've experimented with that a bit, and I've made quite a variety of games. Though getting input does take a bit of space, you can use like an on-click event is your smallest option to get mouse input. Maybe something like on-key down to get keyboard input, or it's possible to even get gamepad input within a pretty small space to create these super tiny games and interactive experiences. So for example, if you wanted to make Flappy Bird fit in 244 bytes of pure HTML, it would look something like this. Basically, you're going to create a canvas, and then the rest of it is all JavaScript, getting your canvas context, setting up an interval, and a little bit of logic for the physics part of stuff. And the only input is using an on-click event. Then to draw stuff, there's a fill rect and a fill text part of it. And the rest of it is just the little bit of logic necessary to run the game. You can do tiny sound in that bit of space as well, though it's really hard to fit because the code to play the sound ends up taking up so much of the space. There's not much left to determine what to actually play. Still, we've done a lot of that. On Twitter, there's bytebeat music is possible. I've released an entire album of bytebeat music on Twitter. And you can even use speech synthesis to create voices which have the ability to tweak pitch and volume too. So there's opportunities there. Let's talk about some of the tweets that inspired me. Check out this incredible underwater tweet by Pavel. I just love this one. It's so simple. Kind of shows you the power of Twitter. Nearly everything you see here will be a for loop and then a fill style and a fill rect is kind of like how a lot of these tweets work. Here's a raycasting demo that's pretty incredible. Blew me away when I first saw it. I love this quarantine door one by Yanni. He's got a nice little optimization here to store fill rect into F and then use that to call fill rect multiple times. A common technique you see on Twitter. This flying paper airplane one is really great. It's done in a little bit of a different way where you have a function that does align to. I love this city traffic simulator by Tom Exor. It's just mind-blowing how he managed to create this city. And the thing that I love the most is the little tiny cars that drive around the city and appear to interact with each other. Yantan did this smoky 3D structure. In this case, it's using the shadow effects to create a kind of a cloudy, smoky 3D blur. So let's take a look at some of my tiny code examples, and I can walk you through how they actually work. Here's the very first tweet that I did way back in 2019. Not my best work, but at the time it was, and I've come a long way though. In fact, I've made over 1,000 of them in the past 4 years. Here's some of the best ones I've done. I've covered a wide range of subjects. Space is one of my favorites. So, for example, to create a black hole type of effect, you can do that by iterating and setting a color and drawing these fill rects. In this case, it's starting from the bottom, iterating up and spiraling out. And that color starts red and goes towards the white. And there's a special test for the very first rect to be drawn to draw that black in the background. You can do fractal rendering in this space very well. It lends itself greatly to tiny code. For example, a tiny Mandelbrot rendering would look something like this. It's using the technique of rendering out 1 pixel at a time to do a super high definition render. Cellular automata is a very powerful effect. Here are a couple of the ones I've done. A lot of different results you can get, such as water or fire type of effects, more of a mathematical type of result. Here's a Sierpinski triangle that's drawn using a 1D cellular automata effect. It's storing the cells into an array and going through and updating all of those cells based on the rule, which is rule 90 in this case. What ultimately matters is the bits of that rule that are used to determine the next state of each cell. I've done so many different experiments with tiny little cities and buildings. I love that kind of thing. For example, this city sunset you can do by, again, looping and setting the color, drawing fill recs. In this case, it draws the background during the very first frame a little bit different than the buildings. And each building is drawn by a grid of squares which alternate between black and colored for the windows. And they kind of are shuffled and drawn from the top to the bottom to create a kind of cityscape type of effect. Really love how this one turned out. One of the more recent things we've been able to do on Twitter is raycasting to really push the limit of what is possible. I've even done a super high definition raycasting system in Twitter, like this tweet here, that draws a city and has shadows and just textures as well. Using that code on the right there, I've done all different types of treescapes, like this tree lake scene. And with some help from the community, we managed to squeeze it down from 194 characters down to only 119 bytes. So it's pretty interesting the way this one works and how it kind of generates a random number, for example. Definitely worth digging into. Drawing from the left to the right for the trees. The very first frame is where it draws the stars or the kind of reflection and horizontal lines. Asemic writing is where you have a writing that looks like it's realistic and means something, but it's actually just fake. I've messed around with that a lot on Twitter. I think it's kind of a fun subject. So for example, if you want to make a super tiny writing system, I was able to squeeze it down to the core essentials here. Kind of like deciding when you're going to have breaks in the writing is the very first line. And then starting and stopping that line using a fill begin path. And for the rest of it, we're just going to draw this scribbly type line, which is moving from the left to the right and the top to the bottom and kind of circling around with different coefficients. I've even managed to fit super tiny people that are running and jumping and fighting and stuff like that. So a little tiny person you could fit in this space by thinking of them as like drawing 4 lines for the 4 limbs. You're starting at the top of the head, drawing down, and each one of those lines is a series of points. So you have a head, shoulder, elbow, hand, and then a very similar thing for the other arm is just kind of offset. And the legs are a little bit longer, but ultimately using the same code. And I'll just blast through a couple more tweets just to give you a sense of the kind of stuff I've created. I've done optical illusions, and even one optical illusion of the year for the dual axis rotation illusion, which I originally posted on Twitter. I've done so many different types of landscapes. They're a really fun thing to play around with. Chaotic systems can have really interesting results. I love how they're just like unpredictable. Physics simulations can fit really well in a tweet, like particles or water bouncing things, or even kind of pseudo physics. I've done all different types of trees, everything from palm trees, bamboo, 3D stuff. Often I'm inspired by mathematical concepts for tweets to make geometric designs. I've done a lot of tunnels and 3D effects. I've done a whole series of words that are kind of like animated to show off that word. It's kind of a weird idea, but it was really fun to try to fit these in a tweet. There are so many more that I've done and other people have done. It's really worth checking out what is there on Twitter. It's just amazing what we've managed to do and continue to keep pushing out new ideas all the time. So maybe if you've watched this whole presentation and are thinking, why write tiny code? Well, I could tell you it's fun and relaxing. It's one of my favorite things to do. It'll also really help you improve your coding skills, and you'll be able to practice prototyping ideas and get much faster at just making things happen. And there's also a community that you can be a part of and even be challenged by competitions like the demo scene. Today, I have a challenge for you, which is to join the Tiny Code movement by creating your own art in 140 characters and share it on social media with hashtag TinyCode. What is the future of Tiny Code? Well, we're constantly discovering these cool new techniques to make new things possible. And browser support is getting better too, which means it's going to look the same across different browsers and mobile devices. Of course, the JavaScript language is constantly evolving, which means that as new features get added, we can maybe have more opportunities to fit things into that space. And computers are getting faster too, so we can do higher resolution output and more complex simulations using the same amount of code. And one of the newest things that's been happening is AI-assisted programming, which can help explain how this tiny code works and maybe even write it. That's all I have to share with you today. I hope my talk inspires you to write your own tiny code. As Da Vinci said, simplicity is the ultimate sophistication. Thank you so much for watching my talk. Keep on tiny coding.
Wow, thank you, Frank. That was a really good talk. I actually enjoyed it a lot because of my experience, not so much of an experience with Twitter, but something I really like about it. But before, actually, I want Frank to join me first to discuss the poll question and also the audience questions. Hi, Frank. It's really nice to meet you.
Hi, Sahar. Really great to be here.
Thank you. That was an amazing talk. We have the answers to your poll question. Can you see it?
So
Yeah.
got it. Okay. So I sent a poll to everyone asking a couple questions, and so the biggest challenge people think are the limited functionality and features, 42%. Interesting, because I think there's unlimited functionality, really. You have as much functionality as you would have without the size. The space is limited. Definitely debugging, I could see that there are some challenges there. I'd love to talk more about that sometime. Readability, maintainability, yeah, obviously when you're golfing it down is kind of hard to maintain, but I think it can be kept clean too. Anyway, do we have another poll or just that one poll?
No, that's just one poll. Yeah.
Interesting.
And then
that's
we
great.
have
Thank you so much for
questions,
answering. Yeah, okay, so let's get to some of those questions. We're limited on time.
All right, as Frank mentioned, we have a workshop for tiny coding with Frank. So if you want to get more insights, join remote workshops after the main conference days. Tiny Game Coding Workshop by Frank Force will take place on October 3rd at 16 CT. Register if not yet, and for the details, you can find it in org emails.
There's a lot to soak in here at JS Game Dev Summit, so it's time for a quick reminder about tomorrow's activities. Join our amazing speakers in discussions on spatial.chat, where our fun topics include AI in creating games, the future of web game development, art in games, and multiplayer games. To chat with me, your co-host Matt Hackett, pop into the Art in Games discussion room. Attendees with full access to conference activities will receive an email with the details on how to join the rooms. I hope to see you there. You've got questions, and we hopefully have got the answers. So get your questions in there. Head over to slido.com and use code 0928. And now it's time for our next talk. Please welcome Ramon with his talk, Ray GUI in Immediate Mode CUI for WASM Tools Development. For those not in the know, WASM refers to WebAssembly. It's a really cool technology. You're going to love it. Ray GUI is a very lightweight immediate mode UI intended for tools development. Combined with RayLib, it allows the creation of small, high-performant WASM web tools. In this talk, Ramon will analyze this specific use case for tools development. But first, Ramon has a question for you, the audience. The question is, Ramon wants to know, are you using WASM-compiled libraries for your web apps or tools development? Let's hear your answers over at slido.com, code 0928. And now, Ramon, the stage is yours.
Welcome, everybody. My name is Ramon Santamaria. I'm an electronic engineer, a professor, entrepreneur, and for the last few years, I've been developing tools and technology for the video games industry. Today, I'm going to present one of those technologies, that it's RightGui, that it's an immediate mode CUI library intended for tools development. Actually, this same presentation, it's a web application, as you can see, that's running on web. And that's the tool. And the presentation itself has been created with RightGui to demonstrate the possibilities and the versatility of this tool. Okay, so let's start. What can you do with RightGui? What is exactly RightGui? Well, RightGui actually is an immediate mode library. It means that it does not store information internally. It's stateless, as said. So actually, all the UI system is based on small functions that are self-contained, that can not only process all the inputs, but also draw all the control in immediate mode. Here is an example. This piece of code in C actually defines a button at the same time that draws the button and receives back the state of the button. It receives if the button has been pressed. If the button has been pressed, is enable a variable that's on the user side. And if that variable is enabled, it actually shows another immediate mode UI control, that it's a message box with some information. You can see that's actually that code generates this button. And when you press the button, you see it generates a GUI message box. Okay, that's all the code needed for the button and the message box, including in itself all the logic. Okay, that's an immediate mode library. Also, the library is really, really high performance. As the backend, it uses another of my technologies, that is RightLib, that it's a popular C library, very high performance in itself. It's code in C. And that code is compiled through mscripten to WebAssembly, allowing to run in a very performant way, all that code on a web platform, on a browser. Also, thanks to being a C library, it is multi-platform. As I said, as you can see, it can run on web, but on a browser, but it can also run exactly the same code, can be compiled for Windows, Linux, Mac OS, FreeBSD, and even embedded systems, Android, Raspberry Pi, more esoteric operating systems like Haiku, or even other operating systems that are supported by RightLib, by the backend. In that regards, the library, RightGui, being an immediate mode library, has a very, very low memory footprint. Actually, the library only requires about 145 kilobytes of memory, of RAM memory. That's the total requirement for the library. And that considers the styles provided. It's a global variable containing 348 properties for the styles that actually you can change. The icons the library provides, as you can see here, those icons are provided by the library. There are up to 256 icons defined, but you can add more if you want. And also the font. The font actually is the most memory expensive element, because it includes several fonts for multiple languages. But on all the styles defined, actually you can see here several styles that can be changing in real time. You see, all those styles are up to 136 kilobytes, including the font texture atlas and all the properties of the atlas for proper rendering of the font. So total memory for footprint is 145 kilobytes. Also, the library includes a set of support tools that allows to edit styles, as you have seen right now. There is a styles editor. Actually, all the styles you have seen have been created with that styles editor. The styles editor also runs online, and it has been also created using Raigi. We will see more about that. There is also another tool that is an icons editor. That it's a tool that has been used to create all the icons that you can see in the buttons and all around. And finally, there is a third tool that is a layout editor. I have to mention that Raigi has not an auto layout mechanism. Actually, the layout must be defined by the user. So the user has full control over all the layout or how everything it's placed around. Okay. We'll see a bit more about those tools later on. And finally, everything you have seen, Railib, Raigi, and all the tools that interact with Raigi, and all the support tools, everything is free and open source, and you can find it here in this link. That's about the features. What about the controls? Okay, here you have a live example of some or most of the controls available in Raigi. You got labels. Actually, those things are labels. You got drop-down buttons, checkboxes. You also have spinners. You got a text box. This is a test. Actually, you can place the cursor, everything. You got a text box. You got combo boxes, different states, Gillis view, toggle groups. Also, you got a color picker selector with alpha bars and hue bars, sliders, progress bar, scroll panels, grids. You even have a bit more rich text box. Okay, those are the controls available. Actually, an interesting point about the controls is that all the controls actually are just a function call. That's what immediate mode UI gives you. And all the controls have these, those are actually the functions, and those are the structure of the functions for every control. It's the GUI control name, the rectangle defining the rectangle of the control, the text contained in the control, and finally some control state variable that should be returned to the user. For example, in the case of list view, the selected item. The same for the toggle group. In the case of the panel, it returns the scroll bar position, the scrolling. Yeah, those are the variables returned. There are usually 1-2 variables as much for every control. And finally, we have a return variable that is some internal state for the control that is returned as required as an integer. So as you see, actually it's pretty simple, the usage of those of that immediate mode UI system. That's regard the controls available. As you see here, actually, you can scale them, move, whatever. Well, that's an interactive screen. And yeah, that's it. About the styles, I've already shown you what's available, but by default, I created a set of styles, like a showcase, showing how everything can be changed in the style. For example, that's a label with a specific size, that's a label with a specific color. Here you got, well, the different styles. With different fonts, you can change the font size, spacing, line spacing for multiple lines. You can configure mostly every style aspect that you can imagine for the UI. As you can see, those are some of the styles I created. Personally, I really like that pixel art UI style, retro UI style for my tools, and all the styles I created follow those guidelines. But actually, you can load any standard font. Well, you can customize the style for your needs to not be so retro. That's it. So that's what we have about the styling. About the support tools, as I said, there are 3 support tools that allow to configure any RightGui application developed for your needs. Actually, there are 3 tools: the GUI styler, the GUI icons, and the GUI layout. The 3 tools are free and open source, and actually they are available online. They are not only available on GitHub. Actually, here you can see the tool on GitHub, but also you got the tool published online that can be executed. And one interesting point is that you can configure the style live, and in the same tool you are seeing live how the tool style is changed. For example, if I change the border color, if I change the base color of the controls, text color, for example, to now something like that. You can change some specific control that affects all the controls, but you can change some specific control. For example, the button. If I want the button a bit different, now I border color. I can change only the buttons now, and well, you can change all the properties. You can also change the font. Well, you have full control not only over all the controls as a default style, but also over every specific control. Okay, you can drag and drop a TTF font and it gets loaded and everything. That's the GUI styler. But you also have the icons editor. It's a simple icons editor. That's it. So here you can edit the icons. Those are the icons that are by default included in RightGui. There are 256 slots for icons. Actually, at the moment, there are still some slots not filled. Some contributors add new icons. Actually, all those icons have been added by contributors lately. And well, at the moment, there are 256, but that can be incremented to whatever number. Yeah, and that's an icon editor, you see. Yeah. So, and finally, probably the most useful and the most interesting tool, considering that RightGui has no automatic layout system, that the layout must be created by the user. It's a layout creator tool. For example, we can place here controls. We have, actually it can be edited. We can place text box, for example, and make it bigger. You can create the layout, and actually it's interesting that all the layouts are referenced by an anchor point, and you can ask how, if it's an immediate mode library that is actually only functions calls, how can I export that layout? Actually, that's the interesting, when you hit the export current layout, actually generates code. It generates automatically the C code for that layout. You can configure if it's C code, if it's containing a header-only file, if you want to export anchors, rectangle. Well, you have several configuration options to export the code in the way you want it to be added to your project. That's the GUI layout. Actually, with that tool, you can create auto-contained layouts For example, file browser, importer, exporter, window. You can create auto-contained windows that can be exported as a self-contained file to be added to any project. That's one thing that I do with my projects. Okay. Beside the support Raigi tools, we also have all those tools. Actually, as I said, for the last few years, I've been working not only on those technologies, Railib, Raigi, and some other technologies, but I've also been, for the last 5 years, I've been focused on tools development using my technologies. Here, there is a set of tools that I have created. Most of them are published and can be used online for free. And some are just internal for me. For example, that's a tool to create tools in a visual way, etc. That's a text editor that has not been published yet. Well, some tools have not been, are not ready, but are not published, but most of them are published and actually can be used online. For example, that's a sound editor that has been created also with Raigi. It's also free and open source. But then you have more complex tools like textures viewer. Well, actually, this tool it's like a canvas to view images, apply shaders, apply transformations to the images, and organize them in a kind of a board. Here you have some example images because I got no images loaded, but you can see what can be done with that tool. It runs online, but it's also available to download as a standalone tool. That's the multi-platform capabilities of Raigi. Texture packer, steganography tool, resource packer, for example. That tool is intended to package, for video games, to package resources, images, text, shaders, models, audios, to pack tools into a self-contained package with different compressions, encryptions for every file. And you also have a installer creator and etc. Actually, the set of tools available, it's quite wide, and actually it proves that well, those technologies work, and they work on web, and they have been used in production for about 5 years now. And yeah, that's it. And okay, wait. Let's go full screen. And well, that would be my presentation of Raigi. I hope you enjoy it, you like it. And now, if there is any question, feel free to ask. Thank you very much. Yeah, that's it.
All right. Well, thank you for that amazing talk. And now, Raymond, join me on stage. Welcome.
Hello.
So good to meet you. How are you?
I'm fine, thanks.
Excellent. All right. So first things first, let's cover this poll. So the question was, are you using any Wasm compiled library for your tools or apps development? So we got no, I didn't know of any, 57%. No, I know some, 14%. And a hard yes, 29%. What do you think? Is that about what you were expecting, or is there any surprises here?
Actually, yes, it was 50% of users. Probably it's higher than what I expected, but I expected at least 20%, something like that. So yeah, it's
nice.
quite close.
Very cool. Yeah, I've heard of WebAssembly ages ago, and I have used some of the libraries. And they're so powerful, and there's just like infinite potential for the things you could use with Wasm, right?
Yeah, actually, I started using it 10 years ago, so
Awesome. All right. Well, that would be our QA, and we're all going to pass it to Sahar.
Thank you, Matt. That was a great talk. And now a word from our sponsors. Yeah, I always wanted to do that. So let's say additional thank you for our sponsor. Poki is the leading company in the web games industry, and they're on a mission to create the ultimate online playground. Reaching more than 50 million monthly active users worldwide, they're responsible for an active and growing community of 350 plus game developers focusing on unique, innovative, and exciting web games to set a new standard on web. Got a game? Share it via developers.poki.com. Back to you, Matt.
Anybody else obsessed with Discord, or is that just me? It's so fun to chat with fellow gamers and developers, and they all seem to be on Discord these days. So be sure to join our Discord server. You can find the link to join in the timeline and your JS Game Dev Summit emails. Here you can get announcements as well as hang out with speakers and our other attendees. To join the Summit Discord, check your email for the invite link. Here is your reminder about a workshop included with your ticket. Join this talk from speaker Assad, adding multiplayer to a simple 3JS game using Playroom. The workshop takes place on October 2nd and starts at 1600 CET. Be sure to register if you haven't yet. Check your email for more details.
Thank you, Matt. And to remind you, please ask your questions to the speakers and they will answer them. And we will ask them to the speaker after the talk. And now, this next talk, I'm a little bit biased because he's my co-MC and I think he's my favorite speaker of the day, Matt Hackett. He's actually going to talk to you about how to make a web game all by yourself. Matt is a game developer who writes, draws, and podcasts. He wrote and illustrated How to Make a Video Game All by Yourself, which has been an Amazon #1 bestseller in multiple categories. But first, Matt has a question for the audience. He wonders, what engine do you use when creating games? That's a great question. And now, Matt, the stage is yours.
Welcome to my talk, How to Make a Web Game All by Yourself. I appreciate you being here, and I think we're going to have a good time. This talk aims to guide you to that elusive finish line and help you ship your own web game all by yourself. But first, a little bit about me. My name is Matt Hackett. I've been making games for fun in environments like QBasic since I was 12 years old. In 2010, I published one of the earliest pure JavaScript games called Onslaught Arena, and I was among the first developers to get a JavaScript game on Steam in the form of a Wizard's Lizard in 2016. Today, I'm working on my new company, Valadria, where I published my book, How to Make a Video Game All by Yourself. I'm also working on 2 new games, Witchmore and Pixel Washer, the latter of which is being written entirely in JavaScript. Let's jump into my talk, How to Make a Web Game All by Yourself. To begin, you are a producer. Making a game by yourself is hard. It's a much different beast than working on a team where you may have lots of different people with lots of different skill sets. You probably have your own skill sets that you're eager to use on your project. I'm sure many of you are programmers, also probably designers, maybe artists, musicians, or writers. These are all fun hats to wear, but to make a web game by yourself, you've got to take off all your hats and consider the project from a high level. So first, think of yourself as a producer. A producer is responsible for shipping a project. Your job is to ship your web game. What you got to realize is that it all comes down to you. When you're not pushing your game forward, it's not getting done. So it's easy to get overwhelmed as a solo developer. One way to help with that is to outsource certain parts of making the game. You don't have to make all of your own assets like sprites or 3D models or sound effects and music and all that. You can make that stuff if you want to, or you can find pre-made assets that you can fit into your project. For me, I used to like to draw all the graphics myself, like for my game Witchmore. But for Pixel Washer, I'm using tons of assets I've purchased from places like Humble Bundle, where I've found hundreds of charming sprites ready to put into my games. The key is deciding when to make your stuff yourself and when not to. In my case, I had an itch to draw a bunch of witches,
and stuff like that involving witchcraft, but I didn't really have an itch to draw a bunch of modern pixel art to wash. What I had was tons of assets burning a hole in my pocket. Both of these were making me itchy, which is our next topic. Scratch your itch. It's different when you're on a team, right? On a team, you likely know your role and what you should be doing. On your own, my advice is to find the tasks that are itchiest to you and do those yourself. For the other stuff, outsource them or otherwise find a way to get them done that's not so draining on your time. If you really want to make your own graphics, you can and should. There's never been so many online tutorials for learning art, nor so many free or open source applications. You can use Krita or the GIMP for 2D images or Blender for 3D modeling. If you don't want to make your own graphics, there are many places to get free assets. My favorite is Kenny. Here you can find hundreds of sprites, both pixel art and high def, 3D assets, user interface graphics, and more. See also Open Game Art for lots of free assets you can use right now. Similarly, if you really want to make your own sound effects or music, you can and should. Web games benefit from the audio element, as well as the Web Audio API, ready to make your game sound great. If you don't want to make your own sound effects or music, there are so many places to get royalty-free music like itch, freesound.org, or freepd.com. So focus on your itchiest tasks, the ones you're really excited to tackle. For the other stuff, consider asset packs or similar solutions to fill in the gaps that you don't want to make by hand. Next, pick a game engine. The biggest game engines of the day like Unity and Godot do have web exports. These web exports can sometimes generate huge files, like hundreds of megabytes for some reason. But these engines can be perfectly fine choices for making web games. For the sake of this talk, let's focus on web-centric platforms. Let's say that means an engine is web-first and either already built on web technology or considers the web its primary build target. With those parameters in mind, there are many great options, but for 2D games, it's hard to argue against Phaser. It's lean, it's mean, it's been around for ages, it does all you want, and it's used by some of the biggest names in the games industry. Also, it's actively maintained by Richard Davey, who's a super cool dude and a great dev. For 3D games, I take a long look at Play Canvas, also supported by super cool devs. Personally, I like to write my games by hand in pure vanilla JavaScript. No libraries, no plugins, just good times with me and my code editor. Yes, I know that's weird. I also like to use the 2D Canvas API because it's nice and clean, and I love how it lets me make sharp, crispy pixel games like those found in my new game Pixel Washer. If you're wiser than me, you might consider making a pure DOM-based game. You'll almost certainly have to touch the DOM a little just to set up whatever else you're doing, but leaning into the DOM can be a smart way to make your game quickly and effectively. The DOM, or Document Object Model, is powerful. It has input elements, scroll bars, buttons, checkboxes, events, cascading style sheets, fancy animations, and text rendering. Like, do you really want to re-implement right to left text? Because the DOM does it right now out of the box. So picking a game engine can be overwhelming, but there aren't really any right or wrong answers. From using Unity or Godot's web export feature to writing your own vanilla JavaScript like I do, it's all good so long as it works for you. You just got to make sure you and your engine meet these two requirements. 1, the engine allows you to make games you can distribute on the web. Easy. 2, the engine needs to click with you, meaning you understand it, you grok how it works, and it's a comfortable tool for you to use. When an engine clicks, you're happy and ready to continue with that tool. Now a note on making desktop builds. If you choose a full-featured game engine like Godot, you're already going to be able to export to the web and other targets like the desktop. But if you're going with a native web engine or writing JavaScript by hand, fear not. There are several tools you can use to make cross-platform builds for your game. Among them are NWJS, formerly Node WebKit, which I think we use for Wizard Lizard, Electron, and Tori. There are also plenty of mobile options, but I prefer to focus on desktop. Now I suggest making the game you want to play. You'll be playing your game a lot as you make it. It's way easier to do this if you actually want to play the game that you're making. Sometimes you might have an amazing idea for a web game that you're sure could be popular with players, but it's outside of the kind of games you like to play. Go ahead and make those games if that's what drives you, but from my experience, they're harder to work on because you come into the project with less domain knowledge, and it's usually less fun for you to spend time with it. If you're making a puzzle game, you'll need to attempt those puzzles over and over again while designing them, so it's best if you enjoy that. If you're adding a jump mechanic, you'll need to repeatedly play with the jump to get it feeling good, so it's best if you enjoy jumping games. Adding a complicated quest, like to an RPG, you'll need to repeatedly play through the steps of the quest over and over again to test them during development, so I hope you think it's a fun quest. Since you must perform these tasks hundreds or maybe even thousands of times during development, it's preferable that you enjoy them. You'll be a happier dev and you're more likely to finish your project. So when you're making a web game all by yourself, I recommend making a game you want to play. Next, you want to find the fun, which is a tricky part of the creative process. Sometimes you know the premise of the game, but you're not totally sure what that one driving force is that makes the game hard to put down. When trying to find the fun, I recommend looking at your game as a toy, and you could make a fun toy out of almost anything. Some of the best toys take inspiration from real life, like bouncing balls, fishing, crashing cars, cooking, or blowing things up. Make toys out of any of those things, and you might just have a fun game on your hands. Additionally, I like to recommend getting lost in the fun of your game. As a developer, you're making a web game by yourself, your game needs to pull you, the only developer, into your game once in a while. You should find yourself kind of wanting to play. You should find yourself working on a bug, but getting distracted by how cool and fun your game is. If that's not ever happening, try to circle back and focus on finding the fun. Once you've found the fun, polish up the core mechanic. Find the funnest thing and juice it up using tweens, squishes, wiggles, sound effects, music, and all the bells and whistles that we can with our web games. Now for a boss battle. Manage your scope. Your scope is your game envisioned in its entirety. Since you're making a web game all by yourself, it's extra important to keep your scope down because it's just you working on the game and your resources are limited. So look out for this game dev boss coming your way, scope creep, the terror of every game dev. Scope creep refers to a project's natural tendency to increase in scope over time. New ideas are constantly arising as the game progresses, players offer amazing feedback that create more work, and before you know it, you've blown up your scope. Scope creep is the enemy of you, the web game producer, whose job it is to ship this game. Here are some tools to help you fight this brutal boss. MVP refers to minimum viable product. In the context of games, try to think about the bare minimum game you have to build to create your trailer or demo your game or just get feedback about whether it's working or not. Build only that and nothing else until the next milestone. Game design pillars provide direction to a project. Your pillars should help you answer questions that are critical to your game's direction. My core game design pillar in Pixel Washer is, it's just about washing pixels. That's it, just pixels. What should I add? Maybe a hunger mechanic? Well, does that help you wash pixels? No, then no hunger mechanic. Should the player be able to run? Would that help you wash pixels? Well, if I could run faster, I could wash more pixels. So yes, you can run. If you're not sure which way to go, refer to your game design pillars to help you answer questions about your game design. And remember this, you are a producer. Take off all your hats. At some point when making a web game by yourself, you've probably made the mistake I've made so many times, which is I kept one of my favorite hats on for too long. Sometimes I draw too many cool sprites I want to use, or other times I add a bunch of sound effects I found, or I've designed a clever level I want to include. But take a close look at some of these things to see if they really work with the game within your scope, or if you need to take your hat off, let the producer in you take over and cut it. And when you cut deep. You've probably got features and content that you think are really cool, and they probably are. But when you're making a web game by yourself, there's nobody else around to tell you no, so you've got to do it yourself sometimes. It's hard. Find any stuff you've built that doesn't support your MVP or your game design pillars, and is otherwise extraneous, and cut it. Throw away your scalpel and your axe, get out your chainsaw. Cut deep to help you ship your game. Next, iterate to the finish line. Finishing is one of the hardest parts of game development. At this stage, you've reached that perilous 90% done state where somehow there's still 90% of the game remaining to make. I like to think of finishing as the final boss, taking the form of a giant swarm made up of tons of bugs and critters and mean little monsters. There's always a million tiny tasks that need to get done to completely finish a game. When you're making a web game all by yourself, these tasks can wear you out because there are so many of them and just one of you. So here are a few ways I like to tackle this final swarm boss by myself. For one, always keep it playable. Look, okay, I know some of you have no idea who I am. Why should I listen to this guy, right? Well, if you don't listen to me, listen to the legendary developer of Doom and Quake. Quote, always maintain constantly shippable code. John Romero. Additionally, here's a list of things I don't do while fighting the final swarm boss. Don't break your build. Don't add anything that breaks other parts of your game. Don't add hungry features that feel incomplete and beg for more work. Don't add something that isn't up to the current level of polish of everything else in the game. And basically, this all boils down to don't set traps for your future self. Here's another tip I like to use. Save it for the sequel. You probably have a huge list of tasks that need to get done. I like to add another list called something like sequel tasks, where I move to do items that are cool, but slowing the current project down. When you're making a web game by yourself, there's nobody around to tell you no, so from my experience, you end up with more ideas for extraneous features and content than you might on a team. Some of the ideas are probably out of scope, but they become precious to you, and you have difficulty parting with them. Celebrated author Stephen King recommends killing your darlings, so listen to him. Kill your darlings, even when it breaks your egocentric little scribbler's heart, kill your darlings. So for these darlings of yours, move them to the save it for the sequel list. Say goodbye, but just for now. This might also motivate you to finish your current game, so then you can eventually focus on those sequel tasks. Now, ship it. You've done it. Good job. Now publish your game on the web. I'm sure some of you have your own web servers, so just upload your game files and you're good to go. If you're looking around for some free options, I got you covered. itch.io, for those not in the know, is the entry-level platform for indie games. There's nothing better. Itch gives you, the developer, full control. Platforms like Apple and Steam are known for taking 30% of sales, whereas Itch lets you decide the split. Highly recommended. On Itch, you'll be in good hands because this is where amazing games like Vampire Survivors and Pixel Washer offer free demos. The emerging pattern among successful indie games seems to be to offer a free version on Itch and a paid version on Steam. As a quick aside, here's a marketing tip. If you want to attempt to elevate your game that nobody has heard of, try placing it next to a platinum bestseller. It's highly effective. In addition to Itch, there is also GitHub Pages, which will host one of your repositories for you for free. This is where I host the GameDev tiers at play.valadria.com, which we'll talk about in the next section. Since we're making a web game, let's take advantage of some of the features unique to the web. Now, obviously, a web game can be inherently online and have multiplayer features, but it doesn't have to. Most of the web games I make are single player, and some of them are download only. But all web games can leverage the web to help promote them or otherwise make them cooler. So let's look at some ways we can do that. Open share pages. This first example is probably the most obvious one. It's really just opening a web page, but this is wonderfully trivial with a web game. As an example, let's look at the GameDev tiers. Can I get a show of hands? Has anyone seen the GameDev tiers before? Nobody? Because I'm alone in my own room? Okay, got it. The GameDev tiers were viewed by over 1 million people, so I made the GameDev tiers maker, which is kind of a web game. It lets you drag around various GameDev tasks and rank them how you see fit. At any point, you can click the share icon, which will open up a web page to whatever Twitter is now, pre-filled with any text you want. Easy and greatly increases a game's potential virality. Continuing with the GameDev tiers as an example, once you've cried your tears, you can download a resulting image. So here is an example. I'll just fill this out real quick. Then we can hit the download button. We find the file. We open it up, and there we have it. Our tears in glorious image format. This is done with the amazing Canvas API. You can create an image element, then draw whatever you want to it using a 2D context. Then turn that image into data and force your user to download it using your weird web hack of choice. These images can then go on to be posted on social media or uploaded all over the place, again, increasing your game's potential virality. Lastly, let's have a big dumb URL party. In this example, we're using my web game Indie Game Sim. This game was made in handwritten JavaScript and is available to play on the web as well as on Steam. So Indie Game Sim is a side-scrolling platformer, but it also lets you make your own levels. These play out in the game as a sort of conversation between you and a monster, but you can also share these levels with friends. There's even a subreddit where players have posted some nightmarish levels, but the real nightmare are these gigantic URLs. They're just way too large. But this made me curious to look up how long URLs can get, and there isn't much agreement between major browsers. Chrome and Internet Explorer cap out around 2K, Firefox at 65K, and Safari at 80,000 characters. So what I'm reading is that you could make a much bigger, dumber game in Safari. You could probably put your whole game in those URLs. Anyway, allowing users to transfer data in this way is an inexpensive implementation that enables the sharing of user-generated content very cheaply. Normally, you might need a database, an authentication, and before you know it, your game's way out of scope. But the web gives us cool tools like URL hacking, so why not stuff a bunch of characters in there and let your players share some data? To summarize, you can make a web game all by yourself. Following these steps may help you out. Keep in mind that you are a producer. Focus on scratching your itch. Pick a game engine you like. Make the game you want to play. Find the fun. Manage your scope. Iterate to the finish line. Ship it and leverage the web. I want to thank you for coming to my talk. For a deeper dive on making your own games, see my book, How to Make a Video Game All by Yourself. For tons of free GameDev articles and videos, see my website, Vladria.com, and my YouTube channel, Make the Game, and my podcast, Make the Game with Matt Hackett. If you have any questions, I will be available in the discussion room at JS Game Dev Summit, or you can find me on Blue Sky and the charred remains of Twitter. Good luck climbing this mountain that is game development, and I'll see you on its slippery slopes.
Hello again. That was an amazing talk, Matt. Thank you. And please, I want to ask you to join me on stage.
I'm back.
Hi,
Here
Matt.
I am again.
Yay.
Hello.
I missed you. Yeah. Hi.
Appreciate it.
Thank
Great
you.
to be here.
Yeah. So let's first discuss the answers to your poll question.
Let's do it. I think you said you were surprised, and I'm surprised as well. 0%
Yeah,
Godot, really?
0% Godot.
I would have
really.
expected to get a bump. It's been getting a bump recently with some of the
Yeah,
Unity stuff going on.
I couldn't vote. That would be my bump. Yeah.
And Godot does have a web export for you web devs out there. Keep it in mind. It's an amazing engine.
Yeah, absolutely. Just use Godot. Yeah.
Yeah.
Okay.
What did everybody think about my talk? Believe it or not, how to make a web game all by yourself was my first talk ever at a conference. I hope you enjoyed it. The talk was based on my first book, How to Make a Video Game All by Yourself. That's a lot of firsts for me recently. So I hope you all enjoyed it. I can't wait to hear what you thought. What about you folks? Anybody working on their first games? Let us know in the JS Game Dev Summit Discord. If you have questions for me or any of our amazing speakers, head over to slido.com and use code 0928. All right, next up, please welcome Anderson with his talk, Game Development with Three.js. In his talk, Anderson covers Three.js, React 3 Fiber, and how to start developing games using 3D libraries and physics engines. But first, Anderson has a question for you. Anderson is asking, have you heard about Three.js before? I definitely have. We would love to know. If you have or not, head over to slido.com, use code 0928. Have you heard of Three.js before? All right, and now Anderson, the stage is yours.
Hi there, my name is Anderson Mancini, and thanks for joining me at the JS Game Dev Summit. We will talk here about Three.js game development and how can you start your journey learning it. So let's dive right in. By the way, I'm 43 years old, creative developer from Brazil, and I'm founder and CTO of Neotix, a company that is based on Brazil, of course, as a creative studio. And I work with companies seeking ways to increase engagement through digital interactions. And I would say that's why game is usually part of my daily routine at my work. And I want to talk to you about how did I ended up knowing about Three.js anyway. Like I usually say that I'm a developer trapped in a designer body. Like I have worked with UI and UX designer since I was 18. But my real passion was always 3D modeling. I love this stuff. And I was seeking a way, how could I combine my 3D knowledge modeling skills that I gained over years with my gaming experience. And about 4 years ago, I decided to bring my 3D modeling knowledge to the web somehow. And I feel that most websites in my country, especially, they lost their appeal after Macromedia Flash became obsolete. And Macromedia Flash was the one thing that I was using when I was creating my stuff before starting in this journey. And then I became aware of Three.js. So it was incredibly hard to find someone to hire for my company at that time. And then I decided to learn it myself, to give a try. And what started as this learning endeavor very quickly became like this passionate obsession. And that's why I'm so excited to be here to give you some tips on your journey, try to teach you how can you improve your way of learning Three.js, and to show you that learning this can be both accessible and very rewarding. So let's talk about what is Three.js anyway. So Three.js is an open source JavaScript library. It is used to create 3D interactive experiences on your browser. And it was created by Ricardo Cabello in 2010. And now it is maintained by hundreds of developers all over the world. I would say me included somehow. And it abstracts the complexity of WebGL, which is like a very complex way of creating 3D for the web. But basically, that means that we can run GPU accelerated apps without running or installing anything extra on your computer, meaning no extra plugins are needed. And it is cross-platform, meaning that your work can run on any browser, and I would say more than browsers. Any modern browser can support Three.js, and we can extend it by using physics libraries, animation libraries, and many more stuff. So you can add functionalities to this application, to this library. And let's see how it looks on code. So I can show you a simple example, very simple example, how it looks on code. This is a simple example. I know it is not exciting at all to have a rotating cube on your screen, but I want to show you how small code that you need to render a rotating cube on your screen. And everything that is written there, it is basically trying to mimic something that happens in our real life. So if it was in real life, that would be like a studio or like a movie recording studio. So to start, you need your scene. So you need to have a place to record your movie. Then you need like a camera to record things. Then you need a renderer so you can see what is being recorded by that camera. And then you have actors or objects that will be recording. And this is exactly what is happening in those lines. So it is very straightforward to understand using this comparison. And I want also to talk about React 3 Fiber. So React 3 Fiber, it is more suitable to you probably if you are more familiar with React framework. And we will see why. React 3 Fiber, of course, is a React renderer for 3JS. It was created by Paul Henschel in 2019, and now it is maintained by hundreds of developers for Point Members community. And you can build your scenes using components to keep everything more readable and more organized. We will see an example in a few minutes. So your components can be reused. It has an extremely extensive ecosystem with a lot of new things being released like every week, I would say. And we have a lot of helpers created by other developers that are available for free for us to use. And we can see like an example on code. This is the exact same, not exciting at all rotating cube, but now we are using React 3 Fiber. And as you can see, it is much more organized and compact because it is using components to structure everything. So of course, the my box component, it is using a composition. So everything that is needed for that specific component is compacted or packed in this component isolated thing. And then you can import that on your canvas and you have the same scene. And here's an example of a comparison between Free.js, which is already short, and React 3 Fiber. So of course it is simpler because it is using components. But what is happening here, it is like basically the same code. Everything is just organized in a different way so you can get better understanding and better usage of the library. And I'm not trying to convince you to use React 3 Fiber or React. I'm just saying the benefits of using compositions on your work. And what is another beauty about components, because they are easy to reuse. So if you want another cube on your screen, all that you have to do is just to duplicate that line, and then you have another rotating cube. And of course, you can pass props. So you can change properties from the inside component from outside, which is great to keep everything organized. And of course, as I talked to you, we have components from Dre. Dre is a collection of growing components and helpers that you can import into your scene, and it is free to use. So if you want to have orbit controls, like I have in this example, we can rotate around now in that scene. All that you have to do is to import orbit controls from Dre library. And it is that simple. And if you want, for example, to have clouds on your project or your game, you don't need to code it. Like someone already did it for you. You just import the cloud component also from Dre, and then you add to your canvas. And it is simple as that. And Dre has more than 150 other helpers like this for you to use. So the secret is to know them by visiting the React Tree Fiber documentation. And let's see now some more exciting examples how you can use React Tree Fiber and Three.js and what can you build with this library. So let's see. Those are some examples of my recent projects. And as you can see, we have like journey visualization. We have product configurators like the GSI Games Sim Industries with that beautiful wheel controller for like car simulation. It is amazing to see things like that running on your browser without installing any plugin at all. And those are other two examples, like one for Dairy Farmers of Canada from Neltic's recent project and Immersive Studios Automotive Showroom. And those are all powered by Three.js. And again, they run with a great performance without installing anything extra on your browser. You can visit those addresses, those links, just by searching on them on Google if you want. And if you want to see more examples like this, you can visit my website andersonmancini.dev or Three.js.org, which is like amazing for getting examples. They have a lot of showcases on their homepage. So you definitely should take a look at that. And of course, we are here to talk about games, not projects. And yes, you can create games using Three.js. And let's see some examples like of games created using this library. Here we have like two amazing examples from Mercy Mitchell, and like they are so beautiful that it's hard to believe they run on your browser and you don't need to install like anything extra. So they are really, really good. And here are some more examples. Like we have the Elysium by Ebenezer, which was released, I guess, last month. And then we also have Choo Choo World by Illusion. Those are also great examples. Some of them are also multiplayer. So you should definitely take a look at those links and see by yourself how they work and how beautiful they are. They really look like an application, not a website. And for more games like this, you should also check this website, webgamer.io, which has a lot of other examples of games using Three.js. And I want to take this opportunity to talk to you about creative development, not only the game development. So I'm creating this game with my friend Leandro Castaño from Argentina, and this will be released soon. So I want to show you a little bit of the creative process. So we start by gathering a lot of references and trying to define a style for a game. Of course, we had this idea to build a pinball machine game using Three.js. And we used, in this case, artificial intelligence to grab references and potential designs on the game. Then we start by collecting assets or creating new assets for our game to create the board and the overall mood we want for that specific game. And then we create a visual concept, which is, of course, like experiment evolves, experimenting with lives, with the visuals of it, and the overall guideline for the game. And then finally, we create the board, like the final layout for the pinball machine. And this is a gameplay prototype. Like it is just to test the physics and the overall interface. It is, of course, currently under development. So be sure to follow us on Twitter or YouTube so you can follow like the progress on this game that we are creating. So the physics works, but nothing else for now. But this is a little bit of the creative process of creating a game. And so you asked, is Three.js a game engine? No, it is kind of. Like the short answer, it is no, because it is a generic 3D renderer. So things like physics, like animations, you need to do yourself. But as I showed you, we have a lot of things that you can add as an extra to the Three.js to transform it in a game engine. And if you want to really dive into the game development using your browser, you should also know about Play Canvas and Babylon. They are more focused WebGL game development. I will not cover them here because it is like another course, let's say, but you should definitely check them out. And I want to share you like a little bit of my learning path. So let's see how we can start learning 3JS. This is my path. I want to tell you that it works for me. I followed this when I was learning it, but your path might be different. So use it with caution, okay? We can like start by mentioning that you need to have HTML and CSS knowledge to start with this. This is a mandatory thing. And also JavaScript knowledge, it is a requirement because everything that we'll be creating will be using JavaScript in the end. So I recommend this course. This course can teach you all the basics of JavaScript if you never saw JavaScript before. You just search for Learn JavaScript Free Camp on YouTube. It is a great course. And if you want to use React 3 Fiber, of course, React knowledge is a requirement. And I recommend you to search for Joy of React course by Josh. It is a paid course, but it has hours and hours of videos and exercises, and it is beginner friendly. So if you never saw React before, don't worry, you'll be covered. And it is another great course. And then after learning the basics of JavaScript, I recommend you to learn 3D software. And why? Because creating a 3D game in a 3D library without having prior knowledge of a 3D software will be very challenging. So I encourage you to learn the basics of any 3D software you want, just to have an interface to play with when you want. And I recommend the Blender 3D, of course, because it is free and it is the one that I've been using all over the years. It is very popular, so you can find a lot of free courses and a lot of free content on internet. And you can start with this tutorial by Blender Guru, and this will teach you all the basics that you need. And you can also learn Spline these days. So Spline is the 3D software used to create 3D interactive experiences in your browser. So it supports native 3JS and React 3 Fiber export. And just to mention, this entire 3D software were created using 3JS or based on 3JS. So you can see the power of it. It is pretty crazy, isn't it? So it all runs on your browser. You don't need to install anything. So you should definitely take like a look at this at least. And after learning the basics of the 3D software, what I recommend is you to follow two possible paths. So you want to learn using free resources would require more discipline and patience from your side, or you can learn by using paid resources to speed up things for you in a more structured way, let's say. And let's start by the free resources. If you just type like 3JS, learn 3JS tutorials on YouTube or any platform, you will find a lot of great things to learn from. I would start with the 3JS documentation because there's a lot of things covered there. So it is a great place to start. If you like books, this Discover 3JS book can cover all the basics that you need. And if you like me and prefer videos, there are tons of videos teaching the basics of the 3JS. And you have a great free course. Just search for this 3JS tutorial for absolute beginners and you'll be covered. And of course, if you want a paid resource, like if you can afford it, the most complete course for sure is 3JS Journey by Bruno Simon. Like it is everything that you need in one place. It has more than 72 hours of video, and you can go from the absolute beginner to advanced. And this is the way that I ended up using to learn 3JS. I would say that everything that I know came from this course. So it is amazing, to be honest. So you should definitely take a look at this. And moving forward, after you have the basics of 3JS knowledge, then you can study more specific game development courses. And we have a lot of them as well because 3JS, it is in the field for quite some time, more than 10 years. So a lot of other developers more experienced than us can teach us. So you have, for example, Nick Lever course, 3JS game development. It is very specific. It is a paid on Udemy. And you also have Baba Sensei course just released free on YouTube, which is great. So they are very great ways for you to start game development. And remember to start with the easy ones and not the most difficult games so you cannot get frustrated with yourself. And after creating your first basic game, you can expand your knowledge. And you can do so by learning, for example, more about 3D modeling, because that will enable you to customize your 3D assets or to create your 3D assets. And you can also learn GLSL shader language, which is I'm sorry, you need to cut this part as well. You can also learn GL. Oh, this one is difficult to say. I'll do again. You can learn GLSL shaders to create unique materials, unique like shaders, unique post-processing effects. It is amazing. You can also learn an animation library like GSAP, React Spring, or Firmware Motion to help you with the animations on your projects. And depending on your game requirements, you can also learn visual effects, post-processing, particle systems, and much more. So, of course, we have disadvantages like anything. Like the biggest issue when we create games using 3JS, it is the performance. And I would say any web platform, but 3JS runs on your browser, so complex scenes can drop the frame rate. But like the browsers are gradually improving on this, so we will be covered probably in some time frame ahead. And would be very hard for me to give you tips on performance because we have limited time here, but we will have a discussion tomorrow. And there I can have more times to share with you some techniques we can do to improve the performance. So be sure to visit us tomorrow for those tips. And one last thing that I want to say, it is like, don't try to learn all at once because it is hard. Like, of course, you need time and start with the basics, create very basic games at the beginning. And this will give you the experience that you need to move forward. So be patient with yourself. And I want to thank you very much for your time. Like, I hope you enjoyed as much as I did. And I hope that my knowledge was helpful to you. And don't forget to follow me on Twitter and on YouTube so you can get more tips and inspiration. And I hope to see you soon. I wish you a great day and bye bye.
All right. Well, thank you so much for that amazing talk. Anderson, please join me on the stage. Here we go. All right. Welcome, welcome. Thanks for being here. How are you?
Doing great. And you?
Doing fantastic. All right. So first things first, we need to get into the audience poll. So the question was, have you heard of 3JS before? I'm expecting most, like the vast majority. And we're seeing 89% yes with only 11% no. Does that align with about what you were thinking?
Actually, no, because like I never noticed that people will talk about 3JS prior to like my talk. And that was fantastic because now people eventually like know about 3JS before, which is amazing, especially on the game community. I don't think most of the people are aware of 3JS and Babylon, those complicated names that only developers know about. So yeah, it is great that 86% know about 3JS.
Interesting. Yeah, I guess the circles I frequent, it seems very popular. It's almost like a go-to. Most devs I talk to when they're like, I want to do, 3D on the web, they're probably not going to write it from scratch, even though that might be their usual MO. And 3JS and Babylon, yeah, they're great choices and very very prolific. All right, so let's.
Wonderful. All right. Well, we're all set, and so we're going to move on to Sahar.
All right, I'm back. Thank you, Matt. Please do not hesitate to share your feedback via the form jsgamedev.com/feedback. The form is open within the whole event, and your feedback would be very helpful to us.
Wow. Today was packed with great talks from amazing speakers on this, the first day of JS Game Dev Summit. We would like to thank all our speakers for sharing their experiences and knowledge with us, and also thank you, our lovely audience, for being with us, for watching, and participating in our celebration of JavaScript game development.
Once again, we would like to thank you to our sponsors for your great support. So Crazy Games, Focus Reactive, Poki, and Evolution Engineering. And a huge shout out to our media partners. Thank you for all our media partners, Solid Jobs, GameDev.js, and GameDev.js, React Jam, and JS13K Games. Thank you all.
Lastly, let's give a thank you and round of applause to the Git Nation team for organizing this amazing first day of JS Game Dev Summit. Woo! Thank you, team. We appreciate you. To attend more conferences from the Git Nation team, get the Git Nation Conference Multipass. Find out more on the Git Nation portal at portal.gitnation.org. Also, in-person tickets for the conference React Day Berlin. The winners will be selected randomly and announced tomorrow on Twitter.
And please subscribe for our YouTube channels, JS Nation and React Conferences. And also subscribe to get more talks from previous events. All of today's recordings will be uploaded to portal.gitnation.org. Check them out there. Full ticket holders will get instant access to them, and free attendees will have access to them at a later date, around a month from now.
Before you go, folks, your feedback really is very important to us. It helps us keep making these events better and better for you. To provide your feedback, please visit jsgamedev.com/feedback. All right. Thanks for being with us today. Thanks so much.
Thank you, guys. It was great. I had a ton of fun, and it was great working with you, Matt, and the Git Nation team, and we had some amazing talks.
Thank you, Sahar. It was so fun co-hosting with you. What a great time. Bye, everybody.
Bye, guys.